Happy Friday, everybody, and welcome back to day 4 of the Go Cloud Architects free AWS Certified Solutions Architect Associate Bootcamp 2022. And we're here to give you a complete free AWS full course to help you get that AWS Solution Architect Associate certification. And the way we're doing this is we're trying to include as much architecture and as many vendor neutral things to help you get that cloud architect job, solution architect job, because we want you all cloud hired. So I'd like to talk about some really exciting things that we're going to talk about. After yesterday, it became clear there were certain things that were needed by the community. So guess what? My team has decided to give you some free learning opportunities to help you out. So first and foremost, I want to talk about the book because my team worked so hard to write this book. And there are about 50 people that wrote this book. So please get your completely free AWS Certified Solution Architect Professional ebook. The link is in the description below. And this is a fantastic book. It includes everything you need for the AWS Certified Solution Architect Associate, the SAACO2 exam, as well as the AWS Certified Solution Architect Professional. And it's one book, so you don't have to read two, because our whole goal is to get you cloud hired and make you a great cloud architect. So you can get that cloud architect job, solution architect job, or that enterprise architect job. Now, to that end, we're going to invite you to a lot of free things. So in 2 weeks, we're going to have the free CCNA, Cisco Certified Network Associate Bootcamp, because the cloud is nothing more than a virtual network and a virtual data center. So we're going to do this live CCNA bootcamp. We're going to make it cloud architect focused for the most part, but it's going to be fun. I've been teaching networking for over 2 decades now. I've taught it to systems engineers at Cisco while I was working there, Riverstone, so it's going to be great. We're going to have a ball. Networking is the most fun thing in the world, so we're going to give you some networking. And that's going to be in the second week. Please register. The link is in the description below. Next week, we're going to invite you to the Cloud Architect Challenge. We're going to invite you all. I will be the CEO, which is reality. I will talk about a business problem, a business challenge, and some business goals. I will invite you all to interview me and to design an actual cloud architecture that's going to meet the business needs. And it's going to be a complicated architecture. It's going to be a real life architecture, the kind of things that I've done for the last 25 years, not made up architecture. So it's going to be an incredible learning experience for you. And I want to make sure you all take advantage of that. Again, it's completely free. We call it the experience webinar, but it's really a cloud architect challenge. If you want to see if you're ready to get cloud hard, you'll know by the end of this webinar. And guess what? At the end of this webinar, if you don't know, if you find out you're not, you'll know exactly what to do to get cloud hired, because I want to build you all the best cloud computing careers, cloud architect career, solution architect career, or enterprise architect career. So to let you know about a new fun thing we're doing for you to help you get cloud hired, we are going to invite you to win a chance to be interviewed by me. We do periodic interviews where we invite the community. We will interview you and we will coach you along the way to help you be more successful on that cloud architect interview, that solution architect interview, so you can get that cloud architect job or that solution architect job and get cloud hired. So that's why we're doing it. And of course, we talked about subnetting yesterday. There was a little bit of confusion. So guess what? We're going to have a free subnetting webinar. We're going to spend hours teaching you subnetting. And we're going to do that before the free CCNA class. And after that CCNA class, I heard a lot of people say they wanted to learn BGP for cloud architects. You know what? After the CCNA program, because the CCNA doesn't cover BGP, and we cloud architects use BGP everywhere, we will run a full BGP for cloud architects course. My team will put up a lead page for that, like a place where you can sign up for it. And that way we can note it, inform you about it. So please like, please comment. Please hit the bell to our YouTube channel, and let's start having fun talking about the AWS Certified Solution Architect Associate exam and the AWS Certified Solution Architect Associate in our completely free full AWS Certified Solution Architect Associate course. Welcome, everyone. If you're here, if you're awake, type Cloud Architect. And I know we're all ready. Everybody will be ready to start their cloud architect journey to get to being cloud hired. So let's start having some fun. Welcome, Amaranth. Welcome, Matt over cloud. Love seeing you folks. I see Eva Doikya out there. I see Ahmed, Avishia over there in Maritas, Nike, Pierre. Wow, so good. Hello, Burkar, Shao. So nice to see you. Daniel, fantastic. Welcome. Amaranth, great network engineer there and a great cloud engineer there. Excellent. Abigail, so good to see you again. Hope you're Hope you're feeling great today. Faisal, I hope all's well with you. Love seeing you guys here. Naga, great having you here. So always honored to be here with so many of you, and so happy. Tosin, welcome. Richardson, it's always good to see you. Mervin Erasmus, I love that name. Cloud Architect. Abigail, Cloud Hired. Yes, that's the whole point. Certifications are good, but if you're not getting Cloud Hired, what's the point? So let's build this community, the Cloud Architect community, and get everybody Cloud Hired. Cunley, it's good to see you today. Nadim, good to see you. And Pierre, Cloud Hired. South Africa, fantastic. Angelo, fantastic. Raphael, Marla. Okay, it's Al. It's so great to see you. Bonaventure Lang, Wow, Ria. It is amazing to see so many great people all over the world. Welcome, my good friend Derek, Randy, Mr. Businessman. Okay, Raphael, fantastic. Cloud Hireds, Cloud Architects. We're all excited. We're getting ready to do some Cloud Architect training, and I am too. And when I see all this many people from all over the world participating, it excites me, and always here. So let's begin. And what are we going to talk about today? Lenny Burnett, it's so happy to see you here. What are we going to talk about today? We're going to talk about starting the beginning, load balancers, because load balancers are an absolutely critical tool to improve system performance, availability. So that's why we use load balancers, to improve performance and availability. So let's start talking about load balancers. Load balancers are one of my favorite techs. Wow, I'm looking at some people that are in Rio, that are in Africa, that are in Asia, that I know some of them are in Europe, India. So wow. I love having such a really fantastic, diverse group from all over the world. Welcome all. Oh, wow, this is great. I just love seeing so many. Yeah, I can't wait for the CCNA. The networking thing is my favorite. So let's begin. Let's talk about load balancers, everyone. First, we're going to begin with what is a load balancer. A load balancer for most of us is a device that distributes network or application traffic. But in the cloud, the load balancer is not a device. It's a virtualized device, but it's still a load balancer. And why do we use load balancers? We use load balancers because they help us with scalability and availability. Here's what they do. If you've got a single web server, and this is the single web server out there, and it fails, you've got no website. But if you've got 10 web servers, and the load balancer can send it to all 10. If a single web server goes away, guess what? You got 9 more. So we always talk about no single points of failure, and load balancers are a device to substantially improve performance by sharing the load across multiple devices. So keep that in your mind. Load balancers are for performance and availability because they remove single points of failure. How do they do it? How do they get rid of these single points of failure? Well, here's what they do. They run a health check. So I've got 10 servers. Server 1, are you there? Yes. Server 2, are you there? Yes. Server 3, are you there? Yes. Server 4, are you there? Yes. Server 5, are you there? Yes. Server 6, are you there? Yes. Server 7, are you there? Yes. Server 8, are you there? Yes. Server 9, are you there? Yes. Server 10, are you there? Are you there? Are you there? Server 10 is dead. Only load share to the first 9 servers. That's how these load balancers work. Just like DNS, just like routing protocols, they use health checks, whether that be hello messages or keep alive messages in BGP or health checks in DNS. It's the same concept. You got something supervising to make sure that it's there, and then something else says, yes, I'm here, yes, I'm here, yes, I'm here. So kind of like taking attendance in class. If you were going to bring 20 people to a certain place, you take attendance. Praveen, I'm so happy to see you here. Cloud Hired. Praveen's one of the best big data architects you'll ever meet, and a fantastic cloud architect and a good friend. I'm honored to see you here today. So keep that in mind. So let's talk about the kinds of load balancers that exist. Now, realistically speaking, load balancers are going to fall into 2 categories. You're going to hear about network load balancers, and this is true if you're on Azure, Google, Oracle, AWS, or you're buying them from F5. It doesn't really matter. A network load balancer is the network load balancer, and what they operate at layer 4. What do they look at? They look at the TCP and UDP header, and they look at the flow, and they are fast. Network load balancers are fast. They are performance network appliances, and they're typically used for things that are big. You've got 50, 128 core servers with a couple terabytes of RAM. You're using network load balancers for them. You want to load balance between firewalls? You're using a network load balancer. Speed and performance is what you're getting out of a network load balancer. Now, the next kind of load balancer we're going to talk about is something called an application load balancer. What's an application load balancer do? It looks at the layer 7 header, HTTPS, etc., etc., etc. Application load balancers are really smart because they're working at layer 7. They're looking inside the application. Okay, now I want you to think about this for a second. You've got two load balancers. They both have 128 cores in them. Now, load balancer 1 does something very simple. Just looks at the network flow. Kind of like math, 2 plus 2. So how fast could you do 2 plus 2 plus 2 plus 2 plus 2? You could do it all day. You're fast. That's what a network load balancer does. It's fast because it only has to do a little bit. Now, an application load balancer is like doing calculus each time. Got to do this. Oh, wow, we calculate a derivative. Let's do some advanced statistics this time. Let's do some complicated algebra. Let's do some linear regressions. Now, how fast are you going to do that? Not as fast as you're going to do 2 plus 2 plus 2 plus 2. So now you know why application load balancers are slow. Network load balancers fast. 2 plus 2 plus 2 plus 2. Quick. Application load balancers calculate the derivative. Well, it's not as fast as I can do 2 plus 2. So now you can think about this. And this occurs in technology. Anytime you ask something to do something simply, it's fast. Anytime you ask something to do something complicated, it's slow. So keep that in the back of your mind. Now, AWS also has another kind of load balancer called a gateway load balancer. That's more for the certified solution architect professional. But what is it? It's a layer 3 load balancer that's designed to load balance between network devices. AWS doesn't talk that much about it. So we're going to stick to the primary ones, the ones that are going to be on the exam, the network load balancers and the application load balancers. AWS also has some old kind of load balancer called the classic load balancer. Guess what? It's the same thing. It's a network load balancer or an application load balancer. And the reality is that's the only kind of load balancers we're dealing with. Now, let's talk about the AWS implementation of these load balancers. The elastic load balancers by themselves will automatically distribute your traffic to multiple targets, such as your web servers or virtual machines. Load balancers are auto-scaling, meaning they have the capacity they need to have. If they auto-scale, they will use an IP address. And the load balancers can load balance between your data centers, also called availability zones. So kind of keep this there. So look into it that way. So the load balancers can distribute to multiple targets. What is a target? The target is the end device. Now, when you're dealing with the AWS load balancers, like I said, they can load balance across multiple availability zones. They support the health check, which is the, are you there? Are you there? Yes, I'm here. Are you there? Yes, I'm here. Are you there? Yes, I'm here. Kind of keep that in the back of your mind. And also the good news is if you're using an HTTPS website, the load balancer can terminate that SSL connection. Again, SSL is encryption. Encryption is CPU heavy. So by offloading the encryption to the load balancer from your web servers are going to be more relaxed. They're having relaxed. They're not doing encryption. They can serve more web pages. They're kind of dancing around, having a party. Now, you put all that encryption overhead in your web service, and they're working hard. They're like shoveling all day long, as opposed to sitting in their office drinking coffee, having a relaxed day. So, we're always trying to offload our servers, decouple our environments, and make the environment better. So what's it really look like? I'll show you architecturally. So here we've got, let's pretend, for example, we've got a website. And what we have is we've got web servers in multiple availability zones. Here's what we do. We use a load balancer, which has the public IP address of the website and the fully qualified domain name, so www.gocloudcareers.com. And when you hit Go Cloud Careers, what happens is DNS routes you to the external IP address of the load balancer. And then the load balancer says, yoo-hoo, send it to data center 1, send it to data center 2. And then, of course, in each data center, we could also, have a load balancer that load balances across these instances. So this is really what we're kind of talking about. It's all about load sharing, removing single points of failure, improving performance. So let's get into some details about these. So when you're dealing with an elastic load balancer, let's talk about the application load balancers first. Remember what I said, the application load balancers, they're smart people, like the kids with the Coke bottle thick glasses that are really smart doing complicated math. Is like the calculus. So this is intelligence going on. And with the intelligence, what happens is it's much more work. So remember, application load balancers are slow compared to network load balancers, which are fast, fast, fast. Kind of the turtle versus the hare, the Aesop fable, if you will. They both get you there, but which gets you there faster? So application load balancers are going to route based on a lot of variables: the path in the URL, elements of the TCP header, the method of the HTTP routing, like push or get, for example, and it can route also based on source addresses. So application load balancers are beautiful for HTTP or HTTP requests, HTTPS requests. They're really nice for load balancing between microservices and containers because we're looking for that intelligence as opposed to the speed. And of course, you know, our load balancers can load balance between our virtual private cloud, which is effectively a virtual private data center, and our data center. And of course, the connections to the load balancer are stateful. It knows what's going on. It's tracking some of these things. So let's kind of look at it. What's it look like? What you can set up with these environments is you've got your load balancer, and they have something called the listener. Are you there? Are you there? Are you there? The listener listens for hellos, and they send hello messages and they listen back. And what happens is you can send your traffic to what's called the target, or what's called the target group. A target is a server. A target group is a group of servers. So kind of like when you create Iam Rolls, you can create a user, or you can create a group of users, say accounting, and apply the policy to the accounting. You can use a target or a target group, which is just an efficient way to group similar people with similar policies. So let's talk about the classic load balancer for a minute. AWS is this concept of a classic load balancer. They don't recommend you use it. It's going to be deprecated at some point, but just realize it's an application load balancer, an elastic load balancer. It does the same things, provides some great logs for auditing, etc. So far, we've talked about that. Now let's talk about internal load balancers versus external load balancers. This is a concept I really want you to know. An external load balancer is as follows. It load balances against public-facing things. So if you had, when we get to the security section, we could talk about it, but if you had a network load balancer front-ending marketplace firewalls for high security, that's an external load balancer because it's external. If you've got a load balancer that's front-ending your website that has a public IP address, it's external. But what if you had internal applications, maybe some critical medical applications that the doctors would use, like an electronic medical record or a computerized practitioner order entry system, something like that? Well, that can't go down either. And that obviously can't be on the internet because people's public records can't be on the internet. But what can be, we've got applications, and are there critical applications in businesses that are private applications that need to be high available and high performance? Yeah, of course. So an internal load balancer is something that's used inside to the organization, where an external load balancer is in front of the internet. So kind of keep that in the back of your mind. When you do this, you're in absolutely good shape. Let's talk about some load balancer concepts. Let's talk about the listeners and the targets a little more. When you're dealing with these load balancers, we have listeners. It literally just speaks and waits for a connection request. So, you know, the listener on that load balancer, and it's going to basically, the traffic's going to come and the listener is going to say, yoo-hoo, oh wait, I got an HTTP request. You go to this server. Another request, go to this server. Another request, go to this server. Or however your load balancing is set up. So there's a listener listening for the connections. Load balancer listens to the connections, and then when it sends it to the server. So the target is where it goes. So we listen, and then we route. What do routers do? They look at something coming in, and they look in the routing table and send out. What does the load balancer do? Comes in on the listener, goes out on the targets. Okay, same thing, just new version of another name. So now let's talk about the target. The target is where the application sends its traffic. Where is it going to send it? Wherever you need it to, your EC2 instances, your virtualized firewalls, which are also on EC2 instances, etc. Now, your target can be an instance, or it can be an IP address. But when the target is an IP address, it needs to be using private address space or come from the shared address space. So the private address space comes from RFC 19, which we talked about before, which is the 10.0.0/8, the 172.16.0.0/12, and the 192.168.0.0/16. Those are the private addresses which we can use, and they're specified in RFC 1918. But there came up with this shared address space that's specified by RFC 6598, and that's 100.64.0.0/10, and these elastic load balancers can use those as a target. So remember, RFC 1918 was when the Internet Engineering Task Force came up with the use of private IP addresses in order to, what's the word I'm looking for, in order to make sure we didn't run out of addresses and accommodate the lack of addresses. So kind of keep that in the back of your mind. So if you ever want to learn how something works, by the way, like the original CSUs like me, the way we learn BGP is not only we read the book, Internet Routing Architecture from Bassam Halabi, but we actually read the standard specifications from the Internet Engineering Task Force. Many of us have contributed to these specifications. And if you go to the IETF.org and you want to find out anything, for example, about DNS, this is your most authoritative source in the world. Want to learn about the OSPF protocol? Go read the RFC. Most authoritative source in the world. It specifies the specification that every other vendor adheres to. So where do I get my information? From the specification and the source. The information I give to you comes from the source. I don't come from whisper down the lane, games. I go to the source. So kind of keep that in the back of your mind. If you really want the most authoritative anything, read the RFC. You'll read the spec. Now it'll be dry, it'll be boring, half of it will be in ASCII characters, but you will get the most deep knowledge that's out there. So kind of keep that in the back of your mind. Let's talk a little bit more about some load balancer concepts. We'll talk about target groups. Like I said, a target is a single user. A target group is like, hey, send it to these 30 servers. Now let's talk about the next concept with load balancers in the AWS cloud, and let's talk about that as sticky sessions. So by default, these application load balancers will send things to the server that has the lowest load, which is pretty smart. If you've got a server that's 80% busy and a server that's 2% busy, send it to the 2%, and poof, you got so much. So keep that in your mind. But what if you want a user to stay on the same server until their session is over? Meaning, send Eva Doikia to server A, send Abigail Marks to server B, send Chow to server C. Well, with network load balancers, that's automatic by the way the flow is, TCP, UDP, poof. But when we're dealing with application load balancers and we're routing on things that are much more complicated and much more intelligent, for example, we're looking at things in the header. Now we don't have the flow. So if you want to keep the same flow on your elastic load balancers, it can be done. What'll happen is we'll utilize a cookie, and the cookie will track the user and the flow, and that's how the elastic load balancer, the application one, can set up something called a sticky session. Now, the last thing we'll talk about on load balancers, which apparently made me internet famous. I didn't try to do this, but apparently people like my version of, are you there? So again, the last thing we need to talk about in these load balancers is the health check. If we're going to have a device that has 5 servers, and we're going to have a load balancer that goes server 1, server 2, server 3, server 4, server 5, server 5, 4, 3, 2, 1, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. That's all great, right? But if server 5 goes away, we've got 1, 2, 3, 4, 1, 2, 3, 4. And if we send it to the dead server, we lose traffic. So that's the concept of the health check. Are you there? Are you there? Are you there? Yes, I'm here. Ding, ding, ding. Good. Are you there? Are you there? Are you there? Remove from the rotation and you're good. So one last thing, application load balancers, lots of intelligence. Network load balancers, speed, performance. Now you know. So I'm not sure if any questions have come up. It looked like, and on one of my monitors, there was stuff coming in from all kinds of angles. And I love that because I love answering questions because I want to make sure you all become the world's best cloud architects and solution architects. You can get that cloud architect job or solution architect job. So Chris, if there's any questions, let's bring some in. Nitropan, how are load balancers highly available? What an excellent question. So when you're dealing in the AWS environment, they're not real. They're logical devices, they're not physical. So logical devices can span multiple pieces of hardware, and that's why they're considered highly available. Now, in the data center, you're dealing with load balancers. And these are high availability devices. They typically have multiple power supplies. They have multiple power supplies. They've got very robust operating systems. They're locked down hard from a security perspective. And you can have your load balancers actually send heartbeats and signals to them so they can provide an extreme level of redundancy. So in the data center, these big, powerful physical devices have their own means to, like a heartbeat health check. Are you there? Are you there? Are you there? To make sure they're there. But in the cloud, what you're dealing with is a logical device. And since it's a logical device, we have nothing to worry about. Chris, you can bring in the next one. It was a great question there, Nitropan. Marek, what kind of load balancer is S5? F5 is the primary manufacturer of load balancers for about the last 20 years or so. And they make network load balancers and application load balancers, but they are the key load balancer supplier. And if you're going to walk into a data center or a cloud provider, chances are they're using F5 load balancers to load balance in between their big servers. So major player in the DNS space and major player in the F5 space. F5 pretty much the king, queen, and everyone else of load balancers, at least physical devices. But great question there, Marek. Chris, you want to bring in the next one? Is there any form of authentication between the load balancers and target instances? Can the load balancer encrypt or decrypt? Well, I'm not sure why you would want to do this, because if your load balancer is here and your server is directly behind it, it's on your private network. So I don't know what you're trying to decrypt or encrypt at all. But your load balancer is going to do the authentication and encryption, at least for the HTTPS SSL piece. So you don't even have to worry about it on the servers. But the load balancers are going to be set up with your servers. Your servers should have access control list. They should have, between your subnets, you should be having security groups between your subnets, et cetera, et cetera, et cetera. But, I'm not sure that there's any reason to encrypt your data between two things on your LAN that only have effectively an Ethernet cable between them that can't be hacked via another means. It's more important to secure your LAN with the right firewalls, IDS, IPS systems, access control lists, security groups, host-based firewalls, et cetera, et cetera, et cetera, disabling unnecessary services. That's going to provide you much more than worrying about a little of encryption on your private network. The encryption becomes critical on your public network, but not your protected private network. Chris, you want to bring in the next one? Event listener is called a listener. A listener is a listener. It could be called, and every device calls it something different. It's just something that listens and waits for connections. And if you're on AWS, Google, Oracle, they all have a listener. They may call it something different, but don't worry about it. It's just a listener. Rajesh. AWS, okay, so Rajesh, yes. The Certified Solution Architect Professional prepares you for the associate and professional test. Here's the reason. I think it's insane to learn one thing to pass an exam and then to relearn something different to pass another exam that's just a deeper version of the same thing. So I can give you a book that's written so simply that it'll get you through the Certified Solution Architect Professional, and it will also get you through the Certified Solution Architect Associate at the same time. And that way, when you're training for the Certified Solution Architect Associate, guess what? You're also being prepared for the Certified Solution Architect Professional. So you can go out there and knock out that Certified Solution Architect Associate with this course and that ebook, and then you'll be 2/3 of the way ready for the Certified Solution Architect Professional and not have to study twice. So yes, we always do it. This little AWS Certified Solution Architect Associate Bootcamp we're talking about today, this is not a Certified Solution Architect Associate Bootcamp. We're covering 3/4 of the topics in the Certified Solution Architect Professional. And why do I do that? Why? Because what's covered in the Certified Solution Architect Associate isn't enough for you to work. So I'm giving you much more. So I want you to maximize it. It all goes to my theory of learn the fundamentals and be really strong. If you know what BGP is, you can work on it on any cloud. If you know what ARP is and proxy ARP, you're going to know how routers do it in every cloud. If you understand what a network load balancer is, I don't care if you're on Cisco, Oracle, the data center, Azure, Palo Alto's cloud, the AWS cloud. Who cares? It's all the same load balancer, network air applications. So that's why we're doing it. So I don't want you to waste your time. The shortest distance between 2 points is the same time, is a straight line. So by mixing it together, I get you cloud hired faster. Now I've got to know the classic load balancer is either a application load balancer or a network load balancer. So here's the way you can think of it. F5 made an application load balancer 25 years ago. F5 made a network load balancer 25 years ago. AWS had a load balancer called the classic load balancer, which was a network load balancer or an application load balancer that works identical to the new elastic load balancers. But imagine that this was called a cell phone, and I wanted to call it a fancy cell phone. I just renamed the same thing, make a slight modification, and now it's got a new thing. So the AWS doesn't want you to use the classic load balancer. They want you to use the network load balancer, but it's just a network load balancer or an application load balancer. So it's kind of like the Who song, Meet the New Boss, same as the old boss. The only thing that changes the name. Chris, you want to bring in the next one? Same thing for John Clark. What's the difference between an elastic load balancer and a classic load balancer? I used to have something called a cell phone, and then they called it a mobile phone. Old version, classic. New version, elastic. Mario, what's the difference between a virtual machine and a VPN? Mario, they are 100% completely unrelated. A virtual machine is a logical part of a server. To create a virtual machine, what you do is you take a bare metal server, you install a hypervisor, and you chop that server into multiple little servers. What a VPN is, you take two internet connections, you create something called an IPsec tunnel between them, and you authenticate each user on the other end. You tunnel your IP traffic, you add some hashes to your traffic to make sure your traffic hasn't been changed, and you push it through the internet. So a virtual machine is basically when you take a server and chop it into many logical servers. And a virtual private network is when you take a public network like the internet and create a little tunnel so that nobody can see what's going through your tunnel, and you have private traffic on a public network. Good question there. Is there any security risk with a load balancer? Any piece of technology you have is a security risk, meaning if you've got something and it's not completely patched and there's a vulnerability, it's a security risk. But as a rule, load balancers substantially improve your security. They provide protection from DDoS attacks, especially because they terminate SSL connections. They can enable your systems to auto scale, which again can provide protection from DDoS attacks. They can remove single points of failure. So realistically speaking, they reduce security risk quite significantly. But any piece of technology, including this mobile phone, can get hacked. So anytime you add technology, if it's not good technology, it can increase your security risks. But as a rule, they make you more abundant, more reliable, and reduce security risks. Tech with Mufaz. Lots of load balancers have lots of things that you can do. And load balancers won't forward bad traffic. So yes, they have some extra built-in security as well. But what kind of attacks can be made on these IDRIC load balancers and how to protect them? Well, anybody out there that's done any penetration testing, maybe using a Kali Linux or a Parrot Linux, you will always find vulnerabilities on everything. So it's up to the user of the load balancer or the security person to start trying to push it. You know, what vulnerabilities exist? What kind of vulnerabilities exist in the load balancer's operating system? Is there any problem with the motherboard that can, or CPU microcode that can be exploited? The same kind of attacks that could be made on a PC could be made on a load balancer. Now, the only difference is, Mohammed, when you're dealing with a load balancer and not a PC, load balancers are network devices. And being network devices, they run a minimal copy of the operating system. They have all these unnecessary services completely shut down. So they're much harder to hack. And that's the same reason we would never use Bastion host, because if you stick a Windows PC in the middle of the internet, that's kind of scary. But if in your demilitarized zone past your firewall, you have a VPN concentrator, which is a security appliance, say, made by Cisco, and this thing is locked down and hardened and rock solid secure, you know, getting past your DMZ is one thing, and then getting past or trying to hack a security appliance is way different than hacking a Bastion host. So these devices are much more secure. Routers are inherently much more secure. Network devices and firewalls are much more secure than the average PC or server. What is the performance degradation? Nog, it's the exact opposite. How much is the performance improvement? You've got one server, you have 10 servers with a load balancer, you've got 10 times the performance. So it's the performance enhancement of the load balancer. Remember, load balancers improve performance and availability. That's why we use them. Chris, you want to bring in the next one? It appears load balancers function like routers. Well, no. Routers function on source and destination IP address, and routers use routing protocols to determine how to build a path through the network. Routers go from one subnet to another. Routers will connect dissimilar networks, etc., etc. Routers run routing protocols. A load balancer is much simpler. It's basically, you come in here, you go here, 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 and here, and it's manual. So they're kind of opposites. Routers do things dynamically, they learn, they're intelligent, and they build pathways and plumbing. Whereas load balancers are like, hey, got 10 servers, share it amongst the 10. Chris, you want to get to the next one? And while we're at it, routers also have health checks. They send messages to each other called hello, hello, or keep lives. Keth, well, how can you connect internet-facing and internal-facing load balancers? Well, if it's in a private subnet, it's internal. If it's in a public subnet, it's external. Best way I can try and describe it to you without, but you know what? When we do that live architecture, that Cloud Architect Experience webinar, we can do some internal and external facing load balancers so you'll understand the difference. How do you make sticky sessions? Well, if you're dealing with a network load balancer, you don't have to, it's automatic. But when you're dealing with the application load balancer, you have to use a cookie that can make sure the connection stays there. Chris, you can go to the next one. There's lots of different ways that you can set up load balancers, from round robin to other algorithms. Some of them run on lowest CPU load. Some can be set up for round robin. You've got lots of flexibility based on load balancers, and your mileage may vary. So every load balancer is different. But nothing's going to give you the features and function like a traditional load balancer like from F5. And also in the cloud, if you need really robust load balancers that are way beyond what you can get from the AWS Elastic Load Balancers, which many organizations will need something better, what they'll do is they'll use Elastic Load Balancer for high availability purposes, and then they'll get some F5 load balancers from the marketplace, and they'll use those F5 load balancers and that good features and functionality of the F5 load balancers to load balance amongst your servers. Chris, you can bring in the next one. It depends where and which cloud, whether you're going to have to pay for an SSL certification, an SSL certificate. Some places you will, other places you won't. What is the difference between VPC and VPN? A VPC is your virtual private data center, the whole place where you stick everything, and where you stick your servers, your storage, or whatever. A virtual private network is you have an internet connection on both sides, and you create an IPsec tunnel, and you secure your transport over a public internet. So one's like have your own building full of stuff, and one's like have a wire through the internet. Okay, so Chris, were there any others? I can probably deal with one more or two more.
Yes, there's several, so I'll find some.
But we spent a lot of time on the VPC piece yesterday, and if anybody missed the VPC piece, please go back to yesterday's day 3. It will be covered heavily. Can you explain how the load balancers distribute traffic via target? Well, yeah, sure. 5 servers. Server 1, server 2, server 3, server 4, server 5. That's it. Chris, you want to go to the next one? What's the difference between stateful and stateless? Well, when you're dealing with a network load balancer, it's going to look at the flow. Source, destination, IP address, TCP, UDP. And that stays there. That's stateful because you're watching a flow. Now, if you're watching what's going on with the header in the application load balancer, that's stateless because there's nothing to track. And that's why if you want to make it trackable, you have to add that cookie. Can you place your load balancers in multi-AZ? Yes, as we've described, you can create multiple availability zone load balancers. Chris, you can go to the next one, and then I think we should get back to the content. How do you gain experience on estimating customers ask from requirement? So if you're asking the question, how do you go from asking the customer what they want to actually how to design a cloud architecture. We teach that in our Cloud Architect Career Development Program. It takes us about 500 hours post-certified solution architect training to actually teach that. That's what makes architects architects. That's why we get paid a lot. That's why people are seriously looking for that. I will give you a chance to see it completely for free next week on that Cloud Architect Experience webinar. But honestly, it takes me hundreds of hours to turn my students into really great cloud architects. And it's about 500 hours after the certified solution architect professional to get my students hired. So it's not something that we can cover on a YouTube Live. But you do that 500 hours, you'll know how to design systems, and the world will come to you, and they'll want you, and they'll need you, and they'll take very good care of you. But, going from certified to architect, it takes me 500 hours for newbies, and it takes me at least 250 hours for people that have worked in tech, unless they're coming from a network or data center background, in which case they've been doing cloud the last 30 years. Okay, so let's get back into the concepts. Now, we're going to talk about security. And when we talk about security, I'm going to tell you the way AWS would recommend you do security. Now, most likely, you will not be doing security this way because your customers are going to want more. But we have to know what they want for the exams. So I'll show you what's going to be in the exam. And when it gets to real security, if you want, I'll show you how organizations will really do it. Because what we're going to talk about in this chapter, most of it is not applicable. Half of it is, and the 50% is not for actual real production work. So if you want to know both, I'll teach you both, because I want you to all get that cloud architect job or that solution architect job. And I want you getting cloud hired. So kind of keep that in the back of your mind. Actually, you know what? To make sure that you're here, before we go out and start talking about security, type cloud architect in the window and do cloud architect and cloud hired. I know you're here. I know you're not sleeping. It keeps me motivated to keep going. By the way, while you're at it, if you can hit the like, comment, subscribe, tell a friend, that kind of thing, that way we can build our channel and get more free content out to more people. There we go. I'm loving looking at this. I know where you're for your names. One second. Okay, I'm seeing these cloud architects, these cloud hires coming in. VNHG, you want some real security? I like that. I'll give you some real security because I'll teach you the AWS way, which you need to know for the exam, and then I'll teach you what your customers are going to demand from you because they want security. So we'll talk about both. Thanks so much. I see you're all there. Thanks so much, Abigail. Okay, let's talk about this. Let's talk about security. So what we're going to talk about in this chapter, and then we'll probably do the reality part if you guys want, is who is responsible for what parts of your VPC, principle of least privilege, which I like to call need to know, industry compliance we'll talk about. We'll talk about identity and access management, which is a whole separate career, but it's important to talk about. We'll talk about multiple account strategies, network ACL, security groups, and WAF. We'll talk about IDS, IPS systems. We'll talk about distributed denial of service attacks. We'll probably talk about the service catalog and the systems manager parameter store based upon, how everybody's paying attention, and there's that. So who is responsible in security? Now, there are enormous numbers of hacking events on the cloud, beyond anything you could possibly dream of. And most of them are related to misconfigured S3 buckets. The remaining ones are due to the confusion of these cloud shared security models. So I'm going to try and make that real clear for you. This causes so much misconfusion. That causes so many outages and hacking. So let's get down to it. The secure security model is simply this. AWS works on maintaining the security of the cloud. Now, nobody can make sure their cloud is perfectly secure, but AWS's goal is to secure their cloud. Now, what do you secure? The stuff that's in your VPC. So they secure the cloud. you secure their VPC. Remember, you have no control on AWS's security. So if AWS gets hacked and you're on the cloud, you're hacked too. So cloud security is a little less than data center security. So for some reason, the cloud providers have said, hey, guess what? Your data center is insecure. The cloud is secure. I'm going to tell you right now, the cloud has every single security weakness that the data center has and more. Plus, the cloud's a high-value target. Hack the cloud? Guess what? Hack all of their customers. Hack mycatcindy.com. Get photos of my cat Cindy. Now, granted, they'll be beautiful photos. She's got cute paws and whiskers and pointy little ears and a beautiful tail. But what are you going to see? Pictures of my cat Cindy. But hack into AWS? All their customers is yours. Hack into Azure? How many customers on their NoSQL database were hacked this year? Thousands. So keep that responsible. And these cloud providers are great, but remember, complexity. So they maintain the security of their cloud. You maintain the security of your virtual private data center, often called your virtual private cloud. So they manage their infrastructure, hopefully, and you manage your infrastructure. So that kind of shared responsibility is a little bit ambiguous. So think about it this way. You're responsible for your IAM users and roles, your patching of your operating systems, the maintenance of your own applications, your security options, such as your network access list, your security groups, your firewalls, your IDS, IPS systems, your VPN concentrators, et cetera, and physical security. So here's my house. Imagine this is in my house, and I always got a couple of switches and routers near me at any one time. So here, now, if I've got a wire connecting this switch to AWS, and this is sitting in the middle of my room, and you just plug into one of these switch ports, you just hacked me. So, all too often, I've got into environments and they're constantly getting hacked, and they've got the right firewalls, the right IDS, IPS system, the right security training, and they've got a router that you can plug directly into that connects you to the network. So, physical security for the devices that connect to the cloud. Security of the data center that connects to the cloud, where your routing is, et cetera, et cetera. So kind of keep that stuff in the back of your mind. That's what we're talking about. So let me show you what the shared responsibility model looks like. They do their compute, their data, their storage, their networking, their availability zones and regions. So if AWS has a networking problem, like their impaired network devices, you can see it can take down your entire environment. AWS has a power failure. I don't know how you have a power failure in a data center that should have redundant power coming in and redundant generators and most likely backup, but batteries. But how that could occur, I have no idea. But you can see that's their responsibility. Their regions, their edge locations, their impaired network or their good network, their storage, their compute, and their databases. So keep that in mind. But what you're doing, your data, your applications, your users, your own personal encryption, your operating systems, your network, your firewalls, your access lists, your security groups, any kind of encryption and decryption you do, and any kind of traffic engineering, that's all you. So keep that in mind. Now, when we're dealing with security, somehow somebody came up with the term principle of least privilege. Now, what does that mean? Only give access to information that needs to know it. The military's got a much better way. Need to know. If you don't need to know it, you don't know it. That is exactly what we're trying to talk about. Need to know. So translate principle of least privilege to need to know, and you'll always know. If you don't need to know it, you won't know it. So that's what we recommend in security. Give someone the minimum privileges necessary to do their job. And the second their job changes and they don't need it, change those privileges. Don't give people the keys to your kingdom. It's only a matter of time until somebody's a bad actor and does something. And it's not necessarily that they're bad. A lot of attacks occur by accident. Well-meaning, well-intentioned people do it. But if the people don't have the right privileges, they can't accidentally make a mistake that can take down your whole network. So kind of keep that in the back of your mind. So need to know. Now, when we're dealing with need to know, we're going to use another term that I absolutely hate, identity and access management, because I don't know what the heck that means. Now, there's another term for identity and access management called authentication, authorization, and accounting. And most of the IAM architects that I know still use the term authentication, authorization, and accounting. And here's what it means. Let's say Jazz is there. I see Jazz is here. Jazz does this. Jazz comes into VPNs into my data center. And Jazz is allowed. Why? I know him. I trust him. Jazz comes into my data center. Now, Jazz wants to go delete a file. He comes in. I authenticated Jazz, meaning I not identify. I said Jazz is Jazz because I checked his username, password, token, or whatever he has. Now Jazz wants to delete a file. Here's what happens. We check his privileges. Jazz goes to delete this file. Yes, yes, yes. Jazz is authorized to delete the file. And what else is the last part of that? It's accounting. I saw that Jazz logged in. I saw the file he deleted, and I tracked it. So that's what we're talking about, IAM. Authentication, authorization, and accounting. So let's walk through these two situations. Now we've got Jazz. Jazz comes in. He wants to get into the management console, and he's authenticated. He wants to make a change. We look up against his AAA stats, his authorization. He's authorized. He makes the change. Now Sally comes in. Sally tries to log into the management console. Sally gets this big X, and it sets off an alarm, and she's not allowed in because she doesn't have privileges. So authentication, who are you? Authorization, what you're allowed to do, and accounting, what did you do? Who are you? What are you allowed to do? And what did you do? That's what we're talking about with IAM. Who are you? What are you allowed to do? And what did you do? So keep that in your mind. When people talk about IAM and you're confused, it's just the identification, authorization, and tracking what you did. So keep that in the back of your mind. Now, when we're dealing with these environments, certain environments have certain security requirements. So AWS and all your main cloud providers support these major security standards. And they could be like the PCI DSS standard for payment cards, things like ISO 9001, 20001, 27001, 2017, 2018, FedRAMP for the government, HIPAA for medical things. So at least in the US. So, AWS will have standards that comply with all these things, as does every cloud provider. And I'll show you how IAM works in a second time. But again, remember, who are you? What are you allowed to do? And what you did. So when we're dealing with AWS, first, for the associate exam, I'm going to give you the rule to follow. On the professional exam, it'll be a little different, so I'll probably indicate that as well. But keep this in your mind. When AWS, you have a user. Who's a user? I'm a user. Iwadoiki is a user. Ahmed's a user. Camille's a user. Dean's a user. Nike's a user. Ria's a user. Because they're a person. And a role is server 1 connecting to server 2. So as a rule, users are humans and roles are systems. So what is an IAM role? You may have worked in the Google environment or the Linux environment, and you've heard of the term service account, which is what one system uses to access another system. The entire world calls it a service account, but AWS calls it an IAM role. But whatever the case is, who cares? It's like a service account. And if you're on Google, it'll be called a service account. And if you're working with Red Hat, it'll be called a service account. But AWS doesn't call it. They call it an IAM role. So IAM user, person. IAM role, server, system, accessing another system. So I showed you a little bit about the identity and access management, but I want to show you one more time. I try to log into the system, and it says Mike Gibbs. Welcome, Mike Gibbs. I see you're Mike Gibbs because I checked your retina. I have your password. And of course, you even used your Google Authenticator because Mike Gibbs is security nuts. So it authenticated me as me. Now I want to upload a terabyte of photos of my cat Cindy. And yes, I probably have a terabyte of videos and photos of my cat Cindy that I adopted a year and a half ago. I love my cat Cindy. So I go to push this terabyte of videos, upload, and it says, you're allowed, Mike, you're authorized. Then there's the accounting thing. So when Chris from my team looks at what's on our crazy cloud bill and he sees a terabyte of cat photos, he's like, Mike, why do we have a terabyte of cat photos sitting on our cloud and our object storage? And I say, Cindy's cute. So somebody will always know what you did. So first it's determined it was me. And then it said, well, Mike Gibbs owns the account, so he's allowed to put photos of his cat. And then accounting side, someone from my team, whether it be Chris or Leo, looks at it and says, Mike, we're paying too much for photos of Cindy on the cloud. Remove them, please. So, that's what we're doing with authentication, authorization, and accounting. So going back to that, IAM users are people. They're created by somebody called the principal, which is basically somebody that's got the IAM ability to do it. So a principal is basically an IAM user, and it's created by somebody with admin access, like the manager, an administrator, or a power user. By the way, and generally with IAM, you've got lots of pre-made policies. Power users can do anything but access IAM, and administrators can access IAM too. So keep that in the back of your mind, because that sounds like it'll be a test question. What's the difference between power users and administrators? The difference is power users can't have access to IAM roles. So there's that. So when you're dealing with IAM users, you can create them via the management console, the CLI, or the software development kit. And IAM users are permanent unless you delete them. So you hire somebody, they get fired. If you don't delete them, they still have access. Not good, not good. Fired person, laid off person, angry person, and they still have access to your systems. How often do you think that causes outages? A lot. Kind of keep that in the back of your mind. It causes a lot of problems. So why are we talking about it? So you know to delete them. So here's the way this will work. So let's say they're your user. User logs in and gets access to maybe some virtual machines, a bucket, or a database. That's how it works. So let's talk about a little bit more about IAM users. We have to define the concept of a principal, which is an IAM entity that has permission to access cloud resources. So the root user, meaning the person who created the account, the root user can do anything. Don't be the root user unless you have to. Like on your Unix system, don't be the root user. And it can be an IAM user, or it can also be a role too, which is basically a server to another server. Now the root user, if you go create an AWS account, you are the root user. Now, that account has unrestricted access, so you could literally do anything. So I don't recommend you use your root user for daily use. You could accidentally delete everything if you're not careful. So for your root account, lock this thing down. Use multi-factor authentication plus secure passwords, and don't use your root account for programmatic access, meaning for one server to another server. Lock this down. So the root user is kind of like my cat Cindy. She's got a crown on their head, and my Cindy can basically do anything. My Cindy knocks at the front door when she goes out. As soon as she scratches at the door, we let her in. Cindy then goes and rubs up against my leg because she wants me to make her shrimp. I cook her shrimp, and when she's done that, Cindy jumps on my lap. And then 10 minutes later, she rubs my leg and she wants me to make her scallops. I then cook her scallops because she's the root user. She can do anything. She can go to any room on my house and do anything, and nobody stops her because she's like royalty. That's your root user. So knowing that, you don't want to let anybody have access to that account. A little more about identity and access management concepts. Remember, it's just about who can access it, what they can do, and tracking them after the fact. So there's a couple ways you could create IAM policies. Let's say you just wanted to create a user one. Okay, so I'm going to look at some usernames that are on my monitor. I'm going to create an account for Priya, Nike, Abigail, Praveen, BNHG, Fraser, Evadoikia, Nitropen, Melody. Now, how hard do you think this is going to be long term, creating an account for 100,000 users? Well, it's not going to scale. And it's not only is it not going to scale, you'll never be able to manage it, not even at all. So every identity and access management platform, whether it be Radius servers, whether it be Microsoft Active Directory, they have the concept of a group. So here's the thing. You can group your users that typically need a similar policy. So a group of systems administrators, a group of security people, a group for accounting, a group for finance, a group for product development, it doesn't matter, et cetera, et cetera, et cetera. That's what we're talking about in terms of groups and users. So if everybody in accounting needs the same policy, just create an accounting group and then add everybody. Okay, so I'm looking at my screen here. I want Eva Doikia, Abigail, Chris Johnson, and Jazz all to be in a group called Disciples. What do I do? And Praveen, I put them in a group called Disciples, for example, and I can give them extra principles or reduce my principles. Otherwise, I can have another group that has no function because I don't trust them. This is the group of scary users. If pop everybody the scary user. What's the scary user allowed to do? Nothing. Whatever the case may be, you make your groups and you give people the minimum necessary privilege necessary to do the job. So what does that mean? Need to know. Don't give anybody things they don't need to know, and you won't be hacked. So what do? How do you create it? You create a group, you provide the permissions to the group, and you add your users to the group. I'm just looking at the slides to see how much more than there is in the IAM section to figure out when is a logical time for you guys to ask questions, because this stuff gets pretty tricky. Let's talk about roles though. Right now, roles are used to provide access for one device to access another device. So before we get into the other things, we've got the IAM user, which equals a person, and we have the IAM role that actually is a role. But of course, there's two things that break those two roles. And that is, we can create something that's called the cross-account role, which is basically a user in one organization that can access information in another information. And then they go from becoming an IAM user to a cross-account role. And the other thing that we'll talk about in this section is something called identity federations. Imagine trying to go to an AWS management console and add your users and use AWS IAM. I wouldn't be doing that. I'm not going to be using AWS IAM. I'm going to set up my Active Directory server like every enterprise in the entire world does. And I'm going to federate my AWS IAM directly into my Active Directory server. Now I can use my corporate authentication server that's going to work everywhere. I've got something simple, something scalable. It's not managed by AWS. We manage it. We control it. I sync that to AWS. I sync it to Google. I sync it to Azure. And guess what? We're using a single Active Directory and it's working. Now we can create our forest and do whatever we need, but I'm using Active Directory. I'm not using any AWS IAM. Guess what? Most organizations aren't either. They're going to federate to an external identity provider like Google. They're going to federate to an identity provider like Active Directory. Could you imagine literally going to the management console all day and trying to do this stuff? We use systems that are built for it. But if it's a two-person company, you're not going to build an Active Directory service. You're going to actually use the AWS IAM service. So really know there's that. So when you're dealing with an IAM role, kind of look at it this way. In the old days, and this was insanity, if you had server 1 that had to connect to server 2, you would put a password on server 1 logging into server 2. Now, in theory, that was great. But if you hacked into server 1 and server 1 had server 2's password, you're now compromised server 2. So we don't love that. And we don't recommend that. So what do we recommend instead? When you create these roles, what happens is when we're creating an IAM role, which is like a service account where one system accesses another system, we're going to be using like a token to make it happen. So what happens, the one device is going to hit an API and it's going to be given a token. And it's going to use that token to act, which is basically a one-time password to access the next system. So have a token, tokens expire, new tokens issued, new tokens issued, new tokens issued. So this way there's no password stored everywhere. Get into one system, you get there. Now, if you got access to the token, a hacker got access to the token, it's only going to be good for a couple of hours. And after that token expires, done. They can't access the systems anymore. So that's what we're trying to do. We're trying to provide security, obscurity, and lock our stuff down. So let's talk a little bit more about IAM roles. IAM roles are used for systems to access other systems. They can be assumed, and that's when you hear assume role by an application or service. IAM roles use short-term credentials, and they use the security token service. The tokens are temporary. The default expiration time of a token is 60 minutes. So 1 hour. Hacker gets it at minute 45. They've got access to that thing for 15 minutes, and they are locked out again. Hacker gets it at minute 1, they've got an hour, but then they're done. So you can set it from 15 minutes to 36 hours. The more frequent the authentication, the more security. The more frequent the authentication, the more overhead. The less frequent the authentication, the less overhead. So you're always going to be training overhead versus performance, overhead versus security. It's kind of that one of the kind of things. So keep that in the back of your mind. So where are these tokens coming from? Well, I'll tell you right now. The tokens are coming from the AWS Security Token Service. It's a temporary security service. Basically, you get your tokens from there, and you can specify the expiration time from 15 minutes to 36 hours. But once these credentials are expired, that's the key, is they're one time, they are gone. So temporary credentials are dynamic, and they get generated every single time. So before we get into cross-account roles and identity federations and single sign-on and Cognito, I want to see if anybody is a little confused. Chris, how long have we spent covering this topic since the last break?
It's been about 20 minutes.
Okay, let's take some questions from the audience, because IAM stuff can make your brain hurt. I know it always makes my brain hurt. It's not something fun like BGP.
Give me just a second.
Sure, no rush. What's more fun than teaching cloud computing? Other than the networking. Mohammed, I'm assuming that means IAM. So IAM is identical to using the TACX for AAA or Radius servers for AAA. Exactly. That's all IAM as well. Great. Mohammed, you must come from a networking background. Chris, you can bring in the next one. Is it a benefit to use an external load balancer from a third vendor? Patrick, what you'll find when you deploy some of these architectures is there are times where the AWS load balancers aren't good enough. They don't have enough features or functionalities and you need more. That's when you use the load balancers from the external vendors. Having said that, those elastic load balancers on AWS are really, really good. And in most cases, you won't need to use an external load balancer like you would an external firewall. But there are organizations that need a much better, richer feature set. And what they do is they create something called an elastic load balancer sandwich, which is they basically use an AWS load balancer for the availability redundancy things. And then they have a bunch of virtual load balancers that are behind that are made by, say, F5, and then they load balance between servers. So there are benefits for doing it, but the question is, do you need it? And in most cases, you don't need it. So I would say it's not something that I do all the time. Most of the time, I can get away with the elastic load balancers. They're pretty solid. AWS did a good job there. Oh, Cindy and Son are always allowed. Wonderful. You know, Chris has got a cat, Sunny, and I love my cat, Cindy. Cat hired Nitropan. Yes. You know what? That's got to be my new thing. Cat hired. My cat, Cindy, she's the best office worker you can imagine. She unplugs Ethernet cables or chews them, powers off buttons with her cute little paws. She unplugs power supplies. She even took down a RAID array the other day. So she's pretty impressive. Cat hired. When assigning the permission to an S3 bucket, which is more preferable, identify a base policy or a resource policy? I generally would recommend that you write the policy that's appropriate for what's needed at the time. It's not that one's better or one's worse. What is appropriate to secure what you're trying to secure? And only know that by asking the customers, what are their goals? What are their business requirements? Without that, we don't really know. In fact, when people are like, Mike, what architecture do I like? And I say, how do I know? I haven't spoken to the customer. I don't know what their goals are. I don't know what their business needs are. I don't know what their pain points are. And that, I don't know what their current systems are. I don't know what their baseline is, because that is the difference between one thing and another thing all the time. So the reason I say communication skills are the most critical skill for the cloud architect is if you don't have great communication skills, you'll never know what your customer wants and you'll never be able to design anything. The cloud engineers are much more technical. Cloud architects are, literally speaking, communication skills are the most critical skill in our job. So it's a hybrid job, hybrid executive, hybrid tech. So Chris, you want to bring in the next one? What's the difference between IAM and policies? Well, a policy is anything. A policy could say, don't leave your house. A policy could say, don't click on this email. A policy could say, you're not allowed to work from home. Policy is just a group of rules. IAM is determining who you are, what you're allowed to do, and then auditing what you did. So what happens, you create a policy in IAM that basically says, Mike is allowed to access this, Cindy is allowed to access this, Phasian is allowed to access this. That's the policy. But a policy is not necessarily required to IAM. You could have a security policy, an employee policy, a vacation policy. A policy is just like what is the expected behavior, versus the IAM, which is who are you, what are you allowed to do, and then tracking what you did. How are an organization's accounts created and managed? How small and large do cloud architects? Okay, so first, cloud architects aren't going to be making any IAM accounts, because cloud architects will never touch the technology. We'll talk to the customer, we'll evaluate their business, we'll design their technology, and then we'll hand it over to cloud engineers that are going to be doing all this stuff. So we're not going to be doing that at all as cloud architects. Cloud architects, we design, and then we hand it over to a build team, which is engineers, and then they hand it over to a maintenance team, which is sysops. So we're not going to be doing any of that. Now, how does an organization do it? Well, it depends on the organization. If the organization is a big enterprise organization, they're going to have Active Directory servers, and they're going to federate to it. If the organization is a big social media player, they'll have both, and they'll have their own identity brokers. Like you could use Amazon as an identity broker, or Google, or Apple, for example. Some organizations are small and they create it. So now again, this goes back to the same thing. Ask the customer what problem they're trying to solve. Ask the customer what the scope of the problem is. Look at, evaluate what the customer needs, and only then can you determine what the right play is. Do I just use AWS IAM? Do we create an Active Directory server and connect to it with AD Connector? Do we connect to an external identity provider? Your business will tell you what the requirements are, and that's how we determine what we're creating. So it's like anything else. When I practice medicine, if someone said, Mike, what disease do I have? And they were 1,000 miles away and I couldn't see them or hear their symptoms, I asked the assistants, I'd say, I have no idea. Now, if they came to my office and I could listen to their heart, I could ask them some questions, listen to their lungs, do an examination, I know what to do. But in these cases, you know, what could an organization do? The organization can do it one of 5,000 different ways, but what do they need to do? So I hope I answered that question there, and that's why I answered it that way. Chris, if you want to bring in another one. Can we talk about SNS, SQS, CloudTrail, and CloudWatch? We can cover that when we cover the SQS, SNS, CloudTrail, and CloudWatch section, which is coming up. Absolutely. Are there multiple gateways allowed to each cloud provider so, you know, AJP, absolutely. Now, AWS has told people, we're highly available. You only need to connect to us once. But you've got AWS with their virtual high availability router and the organization of the data center with a single router and a single link. And if that router crashes, and lots of routers crash, it doesn't matter if the AWS router is there, you're basically dead. So I would never design an environment where I only have one router. I would always have two routers. Now, if I had one router, which I would never do, it would have two control modules, multiple line cards, multiple links in a link aggregation group, multiple power supplies going to different circuits with different UPSs and different power distribution units. So you can make a high availability router, but even still, one is none, two is one, and three is greater than two. So I'm always going to have multiple routers connecting to the cloud. And I'm always going to be connecting to multiple clouds because a single cloud is a single point of failure. And I would never put my customers in a position where the cloud goes down and they die. Imagine a 911 dispatch center on the cloud when the cloud had an outage. People would die. People would dial 911, the police, the fire, the medical wouldn't show up. In a hospital, they get hacked because they're on the cloud. The cloud goes down because of a network failure, control plane failure, or hacking failure. But doctors in the hospital and nurses don't even know how to take care of their patients. They have no concept of their charts. People die. So I don't do anything with a single router, and I don't do anything with a single cloud unless we're dealing with a business that's taking photos of my cat Cindy or a small 5-person business. Of course, we can do one or two more. What's the difference between a key and a token? Same thing. What's the difference between a role and a policy group? I'm not sure what you mean by policy group, Pierre, so I don't want to confuse anything. Pierre, in IAM, if any user doesn't have any group assigned to them, what policy should they have? That's a great question. So here's the key, Priya. You could decide a group policy for systems admins and give it. Or I could make a policy just for you, Priya. And maybe, Priya, you're somebody really special. You've got special, unique needs, and I can give you what policy that you could have. If I want you to have access to everything like the root user, I can do that. If I don't like you, Priya, I can give you access to nothing. So what kind of policy should the user have? The one that gives the user access to the systems that they need to know for their business and nothing else, just like every user. So with every user, what is the minimum level of access that we should give that person? So Priya, If I knew what your role in the business was, then I could determine what that would be. But I would have to know first, and this is why we have to go as architects. We start at the business. So, Mr. CEO, Mrs. CEO, tell me about your business. What are the critical systems in your business? What are your business goals? What are your pain points? What are your competitors doing? Oh, wait, Mr. CEO, you just hired the specialist Priya, and Priya is responsible for the re-architecture of your cloud and data center design. Let's give her access to everything. Root user access, actually. Oh, wait, you just hired this new secretary, Priya, and Priya, we only want her access to your email. Okay, give her access to your email. So Priya, it all goes back to the same thing. We have to ask the customer, what do they want? That's why architecture is not engineering. No one's going to give you this information. No one. No one's going to say, I have this problem. Here's a piece of paper. Go build this for me. No one. We have to find out from the customer what their challenges are, and then we have to design the solution. So you need to know that based upon what the customer told you. But until the customer tells you, you have no idea where to begin. So I hope that makes sense. It's kind of like the doctor. If a patient says, I'm sick, and they don't tell you, I have chest pain, I have shortness of breath, I have back pain, and we don't look at them, we don't do an examination, push. Oh, wait, you've got something around your sphenoid and ethnoid sinuses. Maybe let me look in your sinuses. Maybe you have sinus pain. But I have to be able to look. I have to be able to ask. I have to be able to evaluate. One architect is a digital transformation specialist, a business transformation specialist. How do I transform a business without asking about the business, learning about the business, and knowing about the business? Well, what's the difference between a network access control list and an IAM? Well, a network access control list or an access control list in general is this. Allow 192.168.1.1 to 192.168.1.2 in port 80. It is quite simply a packet filter that enables packets to go from point A to point B. Identity and access management is who is Raul, what is Raul allowed to do, and what did Raul do when he was on my system? So completely different, but great question. What does federated identity mean? Mr. Singh or Ms. Singh, Lion, or I should say, federated identity means instead of trying to deal with the AWS things, you connect it to Active Directory, an external identity provider such as Google, etc. Oh, so let's get out of the IAM role. The only difference, so Pierre, IAM user, human. IAM role, system. IAM role, when a user goes into another account or federates to something else, they become an IAM role. But IAM, think role, system, IAM user, person. A group policy could be a policy that you create for a bunch of users, or it could be a policy you create for IAM roles. A group is just, how do you apply it? So let's say I created a group for the Go Cloud Architect students, and then I had a group for everybody else. I would give additional features and functions to the Go Cloud Careers and Go Cloud Architect students because they're paid students. And the free students would get access to something different. So when instead of looking on this list, and there's lots of people that are here, I would look at Nike, and I would look at Evo Daikia, and I would look at UPR, and I would look at AJ and Jazz, and I would say, Go Cloud Architect students in the Go Cloud Architect group, they can do anything. And I would say, these people, free students, give them access to stuff, but only the free stuff. That's what we're talking about when we say users and group. Great question there, Pierre, now that I understood it a little better. Sorry for not understanding what you meant there before. So let's start talking about some more IAM stuff. And this is the kind of thing where I wish we had my friend Isaac. And Isaac is an extremely good IAM architect. So, but we all have different skills. So let's talk about cross-account roles. So I just told you that a user is a human like me or a Pierre, and a role is when a system accesses another system. Great, right? Well, now we're going to break those rules. If, for example, I am authorized in my system, and then I'm VPC peered to another organization, and they want me to access their stuff, it becomes my IAM user account in my VPC becomes a cross-account role to someone else's. I didn't make this up. So Pierre authenticates into the Go Cloud Architect's cloud. Pierre is an IAM user. Now, The Go Cloud Architects Cloud is connected to my good friend Sandeep Das in India. He's a great DevOps engineer, and we exchange information all the time. Good friend. So Sandeep says you can access my cloud because you're related to Mike's account. When you do that, the user account on your name becomes something that becomes a role on somebody else's cloud. So an Iam role is basically an Iam user in a separate account. So kind of keep that in the back of your mind. And then you'll be good to go. So keep that in the back of your mind. So let's talk about cross-account roles. They can be set up so when user in one AWS account can access another account. Access accounts that you don't own. Okay, so think about this. You're now allowing other people to access information in your account. It's like giving people the keys to your house. So lock this down. Lock it down. So cross-account best practices. Connecting to other organizations can give you business opportunities. Yes, but you can also be hacked. So the partner company immediate access. What kind of access do you give them? Need to know. Principle of least privilege. The minimum necessary to do the job. And anything beyond that, you don't want them to have it because that's only going to come back to haunt you. So keep that in the back of your mind. And then you'll always know what to do. So there's that. Cross-account roles enable you to access another account. So basically you set up one and then you access to something, but you don't know it. I mean, you're not part of that. So the way this is going to work is you're going to create this account, cross-account role, and you're going to need an external ID. And the external ID is going to be uniquely identified with the role. It can be any secret identifier that's known by you and the third party. Cindy the cat. I recommend Cindy the cat. I don't use Cindy the cat for anything because everybody knows my name is Cindy the cat. But if you're ever looking for a great name, Cindy the cat. She's beautiful. And there's that. So, you know, you say you and the third party must share that same thing. Let's say it's Cindy the cat. So when you specify the ID, you're going to specify the trust policy. Who trusts whom? Now, when the third party user goes from Mike's VPC to say Sandeep's VPC, guess what? I have to provide my user ID, that unique ID that we created. And that's how they know I'm me. So the position, I'll be then getting permissions to access things in another account. Cross-account roles. Let other VPCs access your stuff. Beautiful, beautiful, beautiful business partnerships. But when you start giving away keys to your house, if you're not in your house to watch what's going on, stuff's going to get stolen. So be careful who you give those keys to. And maybe if you've got some important, expensive stuff, lock it in a safe. Lock it in a room with a steel concrete door that somebody else has a key to. So that's how you're locking your systems down. Let people come to some things. So I like to think of IAM as this. Somebody knocks at my front door. Let's say it's my good friend Alonzo. Alonzo walks in. Alonzo, here's the key to the house. You're staying with me in Florida. Here's the key to my car. You go have fun. And that's exactly what I would do if my friend Alonzo comes to Florida. And I know he's coming to Florida soon. Now, let's say there's somebody that comes and says, Mike, I'd like to learn about the cloud. And I'd say, welcome, come to my house. And they're like, but I've never met them before. And I say, let's do this. I'll meet you in my office. The office has a separate door, a separate path, and you can knock on the door. I can look and see you in the camera, and I will maybe x-ray you to make sure that you don't have any edged weapons or other types of weapons on you, and then I will allow you in. Basically speaking, I just had two different policies. Policy one is Alonzo. He's my good buddy. Alonzo has access to everything. Policy two is someone I don't know. They're not doing much. So that's why we're talking about. This is how you use security. You have to let people in. When you let them in, you're open to being hacked. So be careful who you let in. Give them access only to what they need, and then you're going to be great. So let's work with this cross-account role just a little more. I love these kind of things. They become fun. You've got company A, company B, company C. We're all having a party. And we authenticate them to go into your VPC. It becomes a cross-account role. Otherwise, if it was just the user in your VPC, you know, they wouldn't become a cross-account role. They'd be a regular role. They'd be an IAM user. So let's talk about how cross-account roles work. A role is created for the user. The user is who the role is created for. And then the external user connects to the security token service and receives a temporary token. Then the user provides that temporary token to the AWS, and then it's authorized. So it's kind of dynamic. And what's cool is you're not actually sending the same password over the wire. So let's talk about Ec2 Roles. So again, when I normally talk about Ec2 Roles, I talk about a service account. Why? Because I'm an old school Linux user, and on Linux, we call it a service account. Google calls it a service account because they're much more open standards. They have some cool branding, but for the most part, they're closer to the generic terminology that the rest of the industry uses. So AWS service roles are just that. They enable one system to access another system. So if an EC2 instance wants to make a secure API call, if an EC2 instance wants to send messages to an SQS queue, if an EC2 instance wants to send messages to an S3 bucket, if an EC2 instance needs to access one of the relational databases, that is a service role. So keep that in the back of your mind. And this kind of service account, Iam Rolls, is so that this device, your app server, can then access your database server. So let's talk about scalability. There's no way in a corporate environment, in an enterprise environment, that I'm going to have 20 people or 30 people or 100 people sitting at that AWS management console all day and creating Mike, Chris, Leo, Ivadoikia, Jazz. Never. I'm not going to have that. That's not reality. So what am I going to really do? I'm going to use Active Directory. Why? Because every organization, or most of them, use Active Directory for identity and access management, just like we used to use TACACS and Radius servers to authenticate our routers and switches, and many of us still do, although some of us use Active Directory for that too. But these are the kind of things that go on. So what do? We federate, or we connect to the identity provider. So how does this federation work? Well, we've got a couple of things that go on. We've got an identity. Send you the cat. Mike, Chris, Jazz, Ivadoikia, Abigail, Chow. That's an identity. Then we have an identity store. That's just the place where all of our identities are stored. So we go to Microsoft AD, and we've got 100,000 users in there because we've got 100,000 employees in our company, and that's how we manage it. Nice, simple, elegant, easy to access by your systems administrators. We can have 8 people that aren't real expensive, and they can take care of our user accounts. Simple Microsoft Active Directory. That's why every company uses it. It's business intelligent. It's functional. It's simple and elegant to use. So then what's the last part of it? Is an identity broker. And that's the application that checks with the identity provider or identity store that receives the credentials. So let's talk about this. Now, I'm going to give you the step-by-step part here. This is ugly. Admittedly, it's ugly, so I'll go over it twice, and it's still going to be ugly even though I do. Step 1, the user logs into their identity broker using the corporate credentials. Step 2, the identity provider authenticates against the LDAP-based identity store. Think Active Directory. The identity provider generates a SAML assertion, security assertion markup language, with all the required information and sends that information to your identity broker. The identity broker will then call an assume role with SAML, which is going to send the token, which is going to hit the AWS Security Token Service API, and it'll pass that SAML assertion and the role for the role to be assumed. And if the API response was successful, it's going to include a temporary AWS Security Token credentials and the associated permissions. And with the temporary credentials, the client application can perform the operation or AWS RAID services. So that's really ugly. It's real ugly. It's real ugly. There's no way around identity and access management without being ugly. So I'll say it one more time. User locks into the identity provider using their corporate credentials. The identity provider authenticates against the LDAP. The identity provider then generates a SAML token. The identity broker calls an STS assume role through the API, and they get the SAML assertion. If the response is successful, it includes the API, the AWS temporary security token, and then it's passed and moved on. So apologies, that stuff was ugly. There's no way to go around that without it being ugly. Let's get away from the ugly and go back to the fun. Just had to talk about it. And mostly that's certified solution architect professional content, but we had to just talk about it. Here's the key as an architect. Why are we dealing with all these identity federations? What's the point? We're dealing with this for this, because we're not going to have users all day play with the AWS IAM solution. We're not going to be using the AWS IAM solution at all, other than to create a few things, and we're going to federate to Active Directory, and we're going to be done with it. Which is why when people say, can I talk about AWS IAM? I'm like, no, talk about IAM, because it's going to be the same IAM on Google, Azure, the data center, et cetera, and it matters. So that's what an identity federation is. We're doing it to make life easy. So I think we'll probably talk about two more things. Let's talk about the concept of single sign-on. So let's think about single sign-on. I could have it this way. I could have Chow enter my VPN access into my home. Then I could have her create another sign-on to go to a virtual machine, have her another sign-on to create this, have another sign-on to create this, have another sign-on to this, and it would work. But Chow's going to call me and she's going to say, Mike, you're super nice, but logging on and these passwords the 4,000 times to get into systems in your house is a little cuckoo. Can we do something about it, Mike? You're driving me nuts. And she'd be right. So what I would say is, let me set up single sign-on. So here's what's going to happen. She logs in and she's got credentials for everything. One time, good security. She's not driving me nuts. She doesn't have to learn 5,000 passwords to use. We've got one password. It uses tokens. We're done. And we're not going to use a password. We're going to use a multi-factor authentication, a key, something. And we're going to have a much more secure environment that's more comfortable and more secure. Let me give you a secret about security. If you make it really complex, your users are going to break it. So here's what happens. If you mandate 128 character passwords, your users will have a bunch of sticky notes sitting on their computer desks with 128 character passwords. When you need an account for everything, your users will store their account in a Word document sitting on the desktop, and they'll be storing it in a public bucket somewhere. If you make your security too unmanageable, your users will work around your security, and their workarounds will be so bad that you will be hacked like you can't imagine. So when we talk about security and we talk about layers, they have to be user-friendly, because if they're not user-friendly, we're going to get hacked. You would be amazed, I mean truly amazed, by some of the innovative solutions I've seen in the last 25 years of people trying to work around bad passwords or bad this or bad anything. So kind of keep that in the back of your mind. So single sign-on is an authentication method that enables users to securely authenticate to multiple applications with one set of credentials. It's usually used in a federated environment. It typically integrates with Active Directory, Azure Active Directory, Salesforce, and other identity providers. It enables the user to authenticate once. So imagine Cindy the cat authenticates. Her paws aren't real good, but she types in the character cat as her password. I don't know why the cat would choose the character cat as a password, but she uses the word cat as a password. So Cindy types C-A-T on the password. She pushes a button with her little paws, and all kinds of things happen. And now she's signed into everything. Now Cindy the cat is sitting by my computer. And Chris, I think you actually have a picture of Cindy sitting behind my computer for the group. And she's typing on the computer, and she's everywhere because she's single sign-in. So she can see the picture of the rat that's walking across. You can see a picture on one screen of the bird that's flying across, and she can see our food because she's a happy Cindy the cat. So single sign-on, and she can access everything. And we don't need to have a picture, Chris, but it was just a concept. I have the single Cindy the cat. So let's look a little bit about what this really looks like. We've got this on-premise Microsoft AD, which is basically what everybody has. Or, of course, you could put your Active Directory in your cloud or data center or wherever, or another cloud. It doesn't matter. And then we connect that to the AWS single sign-in. And that's why we're connecting to these kind of things through the single sign-in. So realistically speaking, that's what and why we're doing it. So log into this thing, get access to everything. So much, much, much better, much, much, much simpler. And of course, I didn't share that screen for you to see it, so let me do it this time. You got your on-premise Active Directory server, and you connect it to the single sign-on, and it's like, yeah, that's great. It's like a boarding pass. Once you get into that airport, you can go get a steak, you can go to the salad bar, you can go to the coffee bar, you can go to your airplane, but you need that ticket in. That's your single sign-on. In once, access to whatever you're allowed to. And even still, they've got permissions, because you go to that airport, this is quarantine off unless you have specific badges or permissions. So single sign-on, that's it. That airport example package is perfect. Thank you for the suggestion. Love it. Let's discuss Cognito briefly. Again, this is a concept for the Certified Solution Architect Professional, but I want you all getting that cloud architect job, solution architect job, enterprise architect job. So I want to give you as much cloud architect and solution architect skills as we can give you. So let's talk about identity federations with Cognito. Amazon Cognito is a service that provides authentication, authorization, and user management for web and mobile apps. It provides a means to connect to identity providers, and Cognito enables organizations to synchronize their identity management and their data across multiple devices. So Cognito will enable users to sign in with a username or password, or with a third-party identity provider like Facebook or Google. And the way it works is going to be as this. The user or the app will authenticate against Cognito, they'll get a token, and then they'll use that token to access AWS. So realistically speaking, this is some pretty cool stuff. So let me show you visually what this looks like. We've got, let's say Jazz. Jazz authenticates and gets his token. He then trades his token for a credential, and then Jazz accesses all our VPC, and he's accessing everything. So that's what we're talking about. Authenticate, get your tokens, access your stuff. So let's talk a little bit more about identity federations. We'll talk about Cognito. It uses the concepts of user pools and identity pools. Here's the user pool. You secure, and that's basically it. So basically, it's a secure directory inside of a Cognito that enables you to manage your users in one place. And after your users get successfully authenticated, they get a token. And what do you think the token's made of? JSON, because all these authentication things are JSON. A little bit more about Cognito identity federations. We've got the concept of Cognito pools. The concept of the Amazon Cognito identity pool provides a temporary token for AWS credentials. Cognito identity pools work with authenticated, but also unauthenticated identities. And Cognito can work with guest accounts, meaning unauthenticated, and authenticated as well, meaning a user who's received a token. So how does the Cognito user pool work? I'm going to go over this real quick, as fast as possible. It's ugly, so apologies. User logs into the identity provider. After they authenticate to the identity provider, they get a session key for the user. They use that session key, and that session key is used for the application to call the Amazon Cognito Get ID API, which identifies the user. Cognito will then validate the session key from the login provider. And if the session key is valid, they'll get a Get ID API with a unique identifier for the user. The user application will send that unique identifier to Cognito. Cognito will verify the session key against the identity provider. And if the key is valid, Cognito will call that again, that same AWS security token service, get a token, and then Cognito will use that temporary token to the application. So as you can see, it's secure and it's dynamic. Now, as I mentioned, it's not, in my world, scalable to try and use AWS IAM. You got to federate to something. So you have multiple options. If an organization has their own Active Directory environment, guess what? They should keep using it. AWS does have a fully managed, dedicated tenant Windows Active Directory server. And basically, it's called the AWS Directory Service, and that is a managed AWS service. It enables you to have two high availability, if you want to call them high availability servers, in two different availability zones that are being used for authentication. And for organizations that use Microsoft-dependent workloads, this is great. But remember, these are hosted servers, but they're an AWS managed service. If you don't want to use the AWS managed service, you can just set up a virtual machine in the cloud and use your Active Directory. And if you're going to use multiple clouds, you might want to just use your own virtual machines with your own Active Directory server and do it manually like you would in the data center across multiple clouds. But, if you want to do it this way, you can use it as an AWS managed service. Personally, I don't use these managed services. I set up my own custom things to work on multiple clouds. Why do I use multiple clouds? Because I want high availability and no single points of failure. So I'm not going to use the AWS directory service. I'm going to use a Microsoft Active Directory system. I'm going to build my own system in multiple clouds, and it's going to be super high availability, high performance, and then it's going to be multi-cloud interoperable. But you can use the AWS directory service as well. It's a good service. Now, when you're authenticating, you hit AWS, you've got a couple of options. You've got a username and password, Cindy the cat, password cat. How secure is that? Cindy the cat, password cat. Passwords can be guessed. You can use a dictionary attack, not the greatest thing. The next way you can authenticate is something called an access key, which is much better. And the access key is a 20-character key ID, pretty long, and a 40-character secret. Well, now you've got something, and you can use this with the API, or you can use it. And now you're getting strong authentication. But guess what? If you really want to lock it down, you can use that access key, which is a 20-character key and a 40-character secret. And you can mix that with a session token. Now you've got multi-factor complicated authentication. And guess what? Now you're secure. You're locked down. You're in good shape. So this is my recommendation. So let's talk a little bit about policies that we can create. So what's going to happen is we're going to create a policy, and the policy will determine what you're allowed to do. So we're going to be writing a policy, and the policy is going to be written in something called JSON, JavaScript Object Notation. And there's going to be lots of ways that we can create our IAM policies in the AWS cloud, and we're going to talk about some of them. We can basically take a managed policy that was pre-made for a set of conditions, which is great. We can create our own. We can use something called the policy generator, and I'll show you different versions of the such. But in the policy, what do we have to do? We have to basically tell them what we're doing, and I'll show you what this looks like. We're going to have something called an effect, which is basically going to say you're allowed or not allowed. We're going to have a service in the policy, and what's going to be in that policy? What do you want to access? So can Jazz access my S3 bucket? Or better yet, maybe I want Jazz to access just this specific resource, and I can do that. And what do I want to happen? Do I want Jazz to be able to read it, write it, delete it? And then I can specify some optional characteristics, very granular controls. So this kind of authorization policy is fantastic. This kind of authorization policy is used everywhere. So kind of keep that in the back of your mind. This is an identity and access management policy. So let's look at what it might be in a couple environments. Look at this. User comes in. They want to access DynamoDB and S3. They can. Now the user tries to go to the management console. Nope, they're not allowed. It's not required for their job function. So that's what we're doing on this authorization side. We're making sure that users can access what they need to access and absolutely nothing else. So how are we going to create the policies? Well, there's a couple ways to do it. A policy, again, is going to specify who can access what and what functions they can. So we can provide very specific resources to the resource name, or we could just do a wildcard. Heck, you can access everything if we chose to. So there are basically two main kinds of policies. They're basically the AWS managed policy and the customer managed policy. And I'll tell you about the two. AWS has some very good stock policies. And these are policies. Microsoft has stock policies too, and they work very well for most use cases. And they're optimized for common use cases and can be based upon job role. Two that you need to know for your exams, I'm going to tell you right now. Administrator access. Cindy the Queen, she can do anything she wants. Power user can do anything except IAM. So administrator, think king or queen. Power user, think princess. They can do almost as much, but they can't necessarily do the IAM. So the king and the queen are the administrators. The power user is anybody that can do everything other than IAM. Keep that in the back of your mind, and you will be rock solid. Now, you can also create your own customer managed policy, and you can do this via one of several ways. Some ways I recommend, some ways I don't recommend. So, and I'll tell you what, how, where, and why these things come from. So policies can be created and managed in a customer's account, and they're not going to be visible outside the organization, but you can custom make them. So let's talk a little bit about making these policies. Simplest thing, copy the AWS policy and make some changes to it. Real simple, real elegant. Don't reinvent the wheel. The people that work for AWS are really smart. The people for AWS know their job really well. So if they're pre-making it for you, it might automatically work. And if it doesn't, guess what? You can just tune it a little bit. Simplest way to do it. Here's your next option. If you're a JSON programmer, you could write your own from scratch. I don't recommend this unless you're a really good JSON IAM programmer. Here's why. If this is not your primary job, you're not going to be as good at it as AWS people are. And if you try and do it this way, you're going to make mistakes. And if you make mistakes, you can get hacked. So if you are a rock solid JSON programmer who's got lots of experience in IAM, like an IAM architect or an IAM engineer, create your own from scratch. You'll be fine. But for the rest of us, don't do it. The last option is something called the policy generator, which gives you a questionnaire, and the questionnaire helps you tell it exactly what you want, and it creates a policy document that, of course, you can edit. And here's what it looks like. Basically, you go to this website, you tell it what you want, you select what you want, and it's going to spit out a policy. And what are these policies going to look like in the end? I'm not an IAM coder. I don't know anything about coding because I'm an architect and not an engineer, but this is what it looks like. Here's your sample IS policy. It tells you what you're allowing. The user can attach or detach an EC2 instance. It specifies which resources are allowed, and it's got a conditional optional thing. That is your standard IAM policy. How do you apply the IAM policy? Well, you either attach it to a user or a group, or you create the managed policy. So let's look at it. I know I tried to draw the concept out of users and groups. So let's think about it this way. We've got our account. I'm going to group my administrators in one set, and I'm going to give them one set of policies. I'm going to put my developers in another group and give them another set of policies. And I'm going to get my testers and give them another set of policies. And in the end, instead of trying to add something to Ben, Joe, and Mark, I'm going to add it to group. And then I'm just going to add Mark, Joe, and Ben to it. For the developers, I'm going to add Dave, Jake, and Emma. And for the administrators, I'm going to add John and Grace. Perfect, simple, elegant. So that's kind of what we're doing. So let's further secure this with regards to multi-factor authentication. And then after this is we're going to start getting into some other cool stuff. So I do want to talk about it with you, but I will probably take a break before we hit that. Let's talk about further securing with IAM with multi-factor authentication. Multi-factor authentication can really enhance your security because if a hacker gets your password, it still needs something else. And multi-factor authentication is not new. In fact, it's really old. We used to have something called MAC cards or ATM cards. They used to be called MAC cards, money access card, 30 years ago. And they used the same concept. Something you have, which is the card, and something you know, which is the PIN. So multi-factor authentication is something you have, your Authenticator app, your Google Authenticator app, your RSA Secure ID, and something you know, your password. So by using multiple factors, it's much, much, much secure. And, we've all seen it. Somebody gets access to your password. They try and break into your account. You get a text message, you change your password, and you're locked down. So it's a great thing. So let's look a little bit about this. User's going to sign into the console. They're going to get a challenge. They'll provide their £1 password, and there you go. Everything is good, and we're in great shape. So before we get into firewalls and DDoS attacks and some of that other stuff, because I feel like once we hit firewalls, you're probably going to want me to show you how to really do it as opposed to the way that AWS would teach you how to do it, and I'm happy to do that, but that's going to take a fair amount of time. So Chris, before we get to that, it looked like there was some cool stuff coming up in the chat box. I couldn't really see it, but I saw some wrenches and lots of stuff going back and forth. So are there any questions we should get to before we get to the firewall section?
Give me just a second to look through it. While I'm looking through it, you can talk about all the exciting things that we have coming.
Yeah, great idea. So first, if you can please like and hit the bell so we do well with algorithms, but please subscribe and hit the bell because we've got so much free stuff coming out soon. I want you to all be notified of it. I want to tell you about some free services that we're doing. To let you know, please download your completely free AWS Certified Solution Architect Professional ebook. The link is in the description below. Please sign up for the completely free cloud computing based, cloud architect based Cisco Certified Network Associate Bootcamp. We're going to teach networking. It's going to be a lot of fun. It's free. The link is in the description below. Please sign up for the Cloud Architect Challenge. It's going to be listed as the Career Web Experience webinar on the page. We will have you, literally speaking, design a cloud architecture from scratch, and you'll get to see if you're ready to become a cloud architect. And if you're not, I'll tell you exactly what you need to be to become ready and get cloud architect hired. We have a completely free interview practice session. Win a chance to be interviewed and coached by me. I've been coaching people for interviews forever. I've never been on a job interview I've never been hired from. And my students do massively well in interviews because we speak to recruiters, CEOs, and hiring managers every day. We know exactly what the customer wants. and we'll teach you that and the free interview thing. And also, please attach yourself to the free subnetting webinar. Why are we doing it? Because IP addressing is the most critical thing. We're going to hold that before the CCNA bootcamp, and after the bootcamp, you guys all wanted a BGP for cloud architects. So after that CCNA, when you guys know subnetting and routing and networking a little better, I'm going to give you a BGP tutorial, the same kind of tutorial I would have done if I was at Cisco, or I would do as I was Riverstone Networks, and it's all free. It's all free. So get your links in the description below, and don't miss our How to Get Your First Cloud Architect Job webinar that we're going to have next Thursday. Again, the link to that is in the description below. So description below, description in the windows. I'm not really sure. I'm just having fun. I'm talking. You guys are here. We're having a conversation. We're doing some training. That's all I know. So I'm doing my best to try and know all the things that we're doing. Charles Simpson, with single sign-on, is that like Kerberos working in the background? I'm not up to speed enough on Kerberos to necessarily talk to it. Single sign-on is like log in once and then have access to everything. So if that's like Kerberos, then yes. Chris, if you want to go to the next one.
It's not necessarily a question, but as soon as I saw this,
okay,
it made so much sense as to what is different about us. You know exactly who's going to be doing this and who's going to be teaching you.
Eva Dike, your first bootcamp was 3 teachers, and they all left and replaced with teachers who couldn't explain it out loud. Mike keeps me focused and engaged. I like that. Kelly, I'm so thankful for that. You know, realistically speaking, we care about our students. I mean, we really care about our students. And the only reason I even came out of retirement to build this organization was as follows. I saw the quality that was out there of the content. And I saw the people that were making architecture classes, and they never were architects until they basically bought a webcam, made up their own course, put it on Udemy, and gave themselves a cloud architect title. And that's why I saw that these architecture classes didn't really equate to reality at all. And I felt so bad because so many people have worked so hard. Now, I've been an architect for 2.5 decades. It's the best job in the world. I love it, and I want everybody to experience these jobs. They're fun jobs. We get paid well. We're treated well. It's the best job in technology. And if you want to go to the CIO or the CTO, or EVP or SVP or VP of engineering, it's perfect because it's a leadership role and a tech role married together. And I love these roles so much. So I'm thankful that you're here and you're focused, engaged. I'm so grateful to have you on our channel. Please join us for the free CCNA materials and let us do anything we can to get you caught hard. It's such a privilege to have you here, Kelly. And Eva Dike, thank you so much for helping with everything. I can only say wonderful things about you every day. You know exactly how much I care, Eva Dike, so thank you so much. And thank you for responding to that as well, Kelly. Appreciate your kind words. Chris, you can bring in the next one. I'm so grateful for that sweet message. You have no idea. And the response that you just left.
Yeah, no, not really many questions right now.
Okay, well, that's okay. We're going to get into security, the real security. So to let you know, I don't consider IAM security. And here's why. There is a role called the IAM architect, and it is a completely separate career. And when you become a cloud architect, here's what's going to happen. You're going to deal with a cloud network architect like me, a cloud IAM architect, then you'll have a cloud security architect, and you'll have a cloud big data architect like Praveen used to be. Now Praveen is an incredible cloud architect who's still a great cloud big data architect as well. But you're going to have people from all different fields. Leverage them, build them together, find the smartest people you know, put them all in a room or in a virtual room, design them together. You'll learn from them, they'll learn from you. And I promise you, what Praveen can do in big data with his 20 years experience is going to be a whole lot better than I can learn in 3 months. So you take advantage of the Praveens, you take advantage of people like me for networking. I know some people that are great on security. You marry that together and you've got the world's best architecture. So architecture is a team sport. Don't get 10x AWS certified. Master whatever it is you're good at and build a team. Do it the doctor way. A doctor doesn't do ophthalmology, cardiology, neurosurgery, and orthopedic surgery. They do one of them and they do it real, real well. Okay, so let's talk about firewalls. And firewalls is one of my favorite types of security appliances. Firewalls keep unwanted stuff out. So let's talk about security. So when you build security, you go from the outside in. And at the outside of your network, you're going to have a firewall. So I'd like you all to imagine a castle, a big, beautiful castle. Now, put a 300-foot wall around the castle, this big, giant wall, so that in order to get into the castle, you'd have to climb a 300-foot wall, climb up the wall, and then somehow not have to fall off the wall on the other side. That's what a firewall is. A firewall by default blocks all incoming connections, every last piece. It allows your internal traffic to breach the firewall and go out, and the firewall keeps track of your going out, so then it allows your return traffic back in. But somebody outside tries to get in, blocked. Mike goes to www.gocloudcareers.net, and I breached the firewall, and the firewall says, Mike Gibbs is going to gocloudcareers.net. And then when gocloudcareers.net says gocloudcareers.net is answering Mike Gibbs, I know Mike Gibbs is here because I saw him leave. That's what we mean by stateful. Firewalls are smart devices. They're intelligent. Now, we'll talk a little bit about firewalls because there's going to be two kinds of firewalls. Well, actually three kinds. There's going to be a WAF firewalls, which are basically layer 7 firewalls that protect web applications and web applications only. There are true firewalls that keep everything bad outside of your organization, including your web. That's what we use. And then there are next generation firewalls, which is now what we're using, which is basically a firewall that also has intrusion detection, intrusion prevention system. So what is intrusion detection and intrusion prevention? It's this. So we built this beautiful castle that's very, very tall, very, very tall. And we've got a 300-foot wall around it. So let's say, climb this 300-foot wall. And we get past this 300-foot wall, we climb down the wall. Now, between the castle and the wall, we've got this giant moat. It's this big, giant lake. And the lake is filled with sharks and alligators and crocodiles and really nasty stuff. So if you get past the firewall, you'll fall into the lake. Now these lions in the lake, we've got crocodiles and alligators and sharks, and they eat you. That's our intrusion detection, intrusion prevention system. But we're not sure if the sharks are going to be hungry, if the crocodiles and alligators are be sleeping or not. So right after we have this firewall, which is the big wall, and we have the moat, we've hired some specially trained lions and tigers and bears. So if you got past our security of the firewall, you'd have to get past our moat, which is our intrusion detection, intrusion prevention system, full of sharks and alligators waiting to get you after you got past. So a next generation firewall is just that. It's a wall that will also attack you if you breach the wall. So when we're talking about firewalls, you could use the AWS WAF, which is a web application firewall to protect your web application, or you can protect your entire enterprise with the next generation firewall. What do you think your customers are going to be asking for? Next generation firewalls. So WAF, which we'll talk about next, is a web application firewall, is good for Mike's website, cindythecat.com, or small businesses. It's great because it's simple and it's cheap and it's a pre-made service. But if you're dealing with an enterprise or a global enterprise, they're going to need more. They're going to need real security, and they're not going to be using WAF. And they're not going to be using the Google version of WAF. They're not going to be using the Microsoft version of WAF. They're going to be using an appliance from somebody like Cisco, Palo Alto Networks, Fortinet, or Checkpoint. That's what they're going to be using. They're not going to be using that AWS service WAF. So you need to know the AWS service WAF for the exam, but don't think you're going to use it in real life. And that's why people don't hire certified people without experience. It's not because they need the experience. They know that if you've just been certified and all you know is all these services, which you don't use anyway in real life, you don't know how to do the job. So I'm trying to give you a little more knowledge on how to do the job. So just know we've got a regular firewall, which protects against everything. We've got a next generation firewall that protects against everything and is self-healing and self-adaptive, and it can detect things that are abnormal and stop them automatically in real time. Or we've got WAF. Let me protect your web application. So you keep that in your mind and you figure out what you're going to give your customer. Reality is, my designs are going on Palo Alto firewalls, Cisco firewalls, Fortinet firewalls, or Checkpoint firewalls, and that's all I'm using because my customers demand security, and I don't want my customers getting hacked, and I don't want customers to think I don't know better. So my customers, when they come to me to design systems for banks or big enterprises, they're using next generation firewalls. So I wanted you to know that before we talked about AWS WAF. So What is AWS WAF? Because it's on your exam. It's a web application firewall, which monitors for HTTP requests or exploits. WAF can be used on a CloudFront distribution, your Amazon API gateway, a REST API, or an application load balancer. And it's going to block connections at edge locations long before they get to your network, which is good. And WAF can control content you specify, just like any firewall. So think of WAF as like a mini firewall for your web applications. It's pre-made AWS. So WAF does give you some relatively granular control of your resources, and you're going to control it with like web ACLs, rules, and rule groups. And basically, they're access lists that'll either deny or permit based upon your policy. And a rule statement is just that. It's a deny or permit. So think of rule groups as individual rules. And of course, WAF will let you monitor your metric on nothing else. AWS logs. What's AWS logs called? CloudWatch. You can see it there. So how does AWS WAF work? AWS WAF works like this following. It enables you enable WAF on the device. You create a policy that filters access to the device. We analyze the traffic based upon the policy. And if a new attack occurs, we create new rules. And of course, WAF will integrate with CloudWatch. So let me show you what WAF looks like. And then if you guys want, I'll show you what's more likely what you're really going to use. So that's the way WAF works. That's your web application firewall to protect your layer 7 web applications on the AWS cloud. So the way AWS would show you how you would do it is they would tell you to put their web application firewall and say your load balancer, which is in front of your servers. You pop your shield there, and there's that. So now let's do this. Let's actually talk about what you're really going to do. Because, let's make this a good instruction for you. So in reality is protecting just your web application is probably not enough, because you want to protect your entire enterprise. If you're connected to multi-clouds and somebody breaks through your WAF, they get access to one cloud, they can attack your data center and your other clouds if you don't have the right firewalls and policies and routing set up in between them. So what's better? Well, it's always better if you can set up your networks to be self-healing, so they heal on their own. So how do you do this? Well, what an organization normally would do would be as follows. Normally we have racks. And we would typically put, firewall 1 in the rack. This is not looking good. Let me try and change the color of this. So we'd have firewall 1. We'd have firewall 2. We'd have firewall 2. Typically what happens is these guys, what they do is they groups. It's not supposed to happen. They typically create something like a VRRP or an HSRP group or something like that, which is like a virtual router. And you typically point your hosts at the virtual router. And these devices are high availability and load share between them. But we're in the cloud. Can you go to AWS and stick a device that looks like this in a rack? No. Well, you can't go to AWS. You don't have a key to the door. They're not going to let you have access to your rack. So you can't do this. So this high availability, high performance firewall that's used by everybody, we can't do in the cloud. So what can we do instead? Well, what we're going to have to do is this. We can go to the marketplace and we can get the world's best firewalls on any cloud provider, and it's going to be in the marketplace. So we're going to use the Cisco firewalls. And the reason we're going to use the Cisco firewalls is quite simply, they're excellent. I worked for Cisco for about a decade and I love the company and they took good care of me. So I've chosen to use a Cisco next generation firewall. Next generation firewalls are self-healing, self-adapting. Now, if I was in a data center, I'd have these two great firewalls in a rack and they'd be high availability, they do heartbeats, etc. But I can't do that in the cloud. Why can't I do that in the cloud? Because I can't physically plug a hardware device in there. But what can I do in the cloud? I can go to the marketplace and launch a firewall. Now, where does that firewall sit? It sits on a virtual machine. What does AWS call their virtual machines? EC2 instances. What does Azure call their virtual machines? Virtual machines. What does Google call their virtual machines? Compute engine instances. So Oracle calls them virtual machines. So with any of our cloud providers, we're going to go to the marketplace and we're going to get that Cisco next generation firewall. But does anybody think this mobile phone by itself is a high availability device? Absolutely not. Does anybody think a virtual machine itself is a high availability device? I hope not, because it's not. So if a virtual machine's not high availability and the virtual machine crashes, we lose our firewall. So we need two virtual machines when we're dealing with virtual firewalls. So 2 of them. Can any of you guys type in the chat box what kind of device that we could use to increase performance and availability to load share across 2 virtual servers or physical servers? Can anybody think of that device? Pop it in there. The device that would enable me to send traffic to 2 different virtual machines, so that if one virtual machine dies, the other one will be there, and I can send power back and forth, load share, improve my performance and availability. It's a load balancer. Exactly. We're going to use a network load balancer. So that's what we're going to do. In reality, in almost all cloud security environments, you're going to use a network load balancer, and you're going to put it in front of your next generation firewalls. So for the external entity to the world to see, they see this one IP address over here. But what's really going on is you're being filtered by both of these firewalls. So that's reality. Reality is most people don't secure their enterprise with a service that's designed for layer 7. Now, there are certain really high-end WAF products that get integrated into a big security environment, like Zscaler, that have full end-to-end really great solutions. But as a rule, this is what most organizations do. This is a massive, massive, massive market, and this is next generation security. Adaptive security works, heals on the fly, so keep that in the back of your mind. So now that we talked about firewalls, let's talk about DDoS attacks and how we prevent them. And the good news on the cloud is we can do more to prevent DDoS attacks in the cloud than we can do outside the cloud. And that's one thing that I love about the cloud. So what is a DDoS attack? A DDoS attack, or a distributed denial of service attack, is as follows. You got a bad guy or girl, bad hacker, that really bad person is in red. They're infected, they're bad. They want to crush our web application. So what do? Our web application is able to handle 10,000 requests per second. Any more than that, it can't handle it. So what happens here? The attacker and his server infects a lot of servers out there. Infected, 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 infected. And then the hacker now has control of all these infected servers. So it's like the master zombie in charge of a bunch of zombies in a zombie movie. So now the king and queen zombie tells all these zombies to go attack that web server. And all those zombies run towards that web server. And the web server can handle 10,000 requests per second. But the zombies hit it with 100,000 requests per second. And guess what? The zombies take all the web requests. And while the zombies have overwhelmed that web server, Cindy the cat that wants to go see her Cindy the Cat website can no longer access cindythecat.com. She's sad. She's meowing because she wants to get there, because really this attacker, this bad guy, affected all the zombies. So what do? We make it that the zombies can't affect us so much. And there's lots of ways to do it. So let's talk about preventing these DDoS attacks. Typically speaking, in order to prevent a DDoS attack, we need a massive end-to-end security posture. And massive, it is not a single service. Now, there are services that can help us block against DDoS, and they are excellent. Cloudflare has them, Google has them, AWS has it with Shield Standard and Shield Advanced. These are excellent services. What do these services do? Well, typically speaking, we're setting up a content delivery network. And a content delivery network is a network that also has a bunch of servers and caching servers on there. But the key point to remember is that it is a network. A content delivery network is a network. So kind of keep that and remember that. So what happens is that when you use a content delivery network, the user goes to the content delivery network, and if it's a legitimate request, it goes to the web server. But if it's an illegitimate request, it doesn't go to the web server. So the content delivery networks will drop bad requests, which will mean our web servers won't see them. So if the 100,000 requests we're getting are bad requests, and we're using a content delivery network, guess what? They're all dropped, which means they never affected us in the first place, which is great DDoS protection. So if we're using a AWS WAF, it can kind of recognize some of these things and dynamically fix them. If we're dealing with an enterprise-grade firewall, the time we're talking about a next-generation firewall, massive DDoS protection in them. They'll reset TCP connections. They'll do all kinds of cool stuff. Now we're also going to use the DDoS protection like Shield. What's going to do? It's going to literally block bad requests before it even gets to us. So every content delivery network has one. It's fantastic. Shield is standard. It basically comes free if you're using WAF. Shield Advanced is not free. It's a couple $1,000s per month, but it's very good. And it provides a real protection to your EC2 instances, load balancers, CloudFront distributions, DNS, and global accelerators. So this is very good service. And truthfully, if I'm on AWS, I'm using Shield Advanced because it's quite good. Now, Shield Standard is basic. It's free with WAF. According to AWS, it blocks against 96% of the most common attacks: SYN attacks, SYNAC floods, reflection attacks, HTTP slow reads, etc. And, it's box-based on policy. So Shield Standard is static, so policy. So you get an attack that it's not familiar with, doesn't do anything about it. So that's why Shield Standard is probably not optimal for anything other than small businesses. Now, big businesses need Shield Advanced, and Shield Advanced is robust because Shield Advanced gives you substantial protection. It provides intelligent attack mitigation. Something happens, like an IDS IPS system. It's smart. Block, allow, block. It's smart. Deploys ACLs on demand, whatever it needs to. So Shield Advanced gives you some extra visibility and notifications in layer 3, 4, and 7 attacks. So when we're talking about Shield, we're advanced. We're talking about some really good services. Plus, if your customer has advanced Shield and they're on business or enterprise support, they've got a 24/7 DDoS response team. And that's really important. And here's the reason why it's so important. Stuff happens. And if you're not dealing with DDoS attacks 24 hours a day, 7 days a week, it's not your specialty. And if you call a DDoS team that does nothing other than DDoS, they're great. I spent my life on BGP. BGP is so simple for me because it's where I spent my life on. For the rest of the world, it's complicated. So when people research for 3 weeks and have a BGP question, then they come to me and I can answer in 2 minutes. Why? Because I'm an expert on BGP. Now, if somebody asks me something about Python, it may take me 6 months to answer their question because it's not my area of strength. It's not who I am. So use the right thing. So if you've got access to a 24/7 DDoS team, that's all they do. They're going to be real good at it compared to the average user that calls it what? Once every 15 years? So deal with experts. You'll always get better outcome. While we're here, again, mostly if we're using our next generation firewalls, we got all this stuff done. We don't have to think about it. But if we're not, let's start looking about some other things. So we've got GuardDuty, which is an Amazon service that can help you monitor your accounts. It'll analyze your CloudTrail logs, your DNS, your VPC flow logs. It'll look for patterns of behavior of compromised systems, and it'll send you an alert. But guess what? Your next generation firewalls with IDS IPS systems will do the same thing, and it's there. But GuardDuty is a good additional service. And if you're going to be using things like WAF, you definitely need GuardDuty. Let's talk about Amazon Inspector, which is another automated security assessment service that helps improve the security compliance. And what it does is it inspects your applications for exposures, vulnerabilities, deviations from best practices. And after it provides an assessment, it gives you a detailed list of results. And basically, it helps you check your network with these results. Here's the thing. Automated. How accurate do you think automated things are? Terrible. So like in medicine, we've had these decision support systems forever. I go to write a prescription. It'll generate 50 alerts for every prescription. Every doctor every time says, ignore alert, ignore alert, ignore alert, ignore alert, ignore alert. Basically, if I want to give somebody an aspirin and they're over 40 with high blood pressure, it'll give me an alert. It'll give you an alert for everything. And here's the thing. The professional, the doctor, knows when to write that prescription and when it's safe and not safe. The alerts are so busy and so toxic that what happens is that everybody ignores the alerts. And then when the alert actually means something, we don't even see it. So realize when you're going to deal with one of these automated systems, it's going to give you millions of alerts. Now, I'm exaggerating the concept, but it's going to give you a lot. You have to look at it as somebody that's educated and capable and knowledgeable and know if that alert's meaning something or nothing. Because a lot of the time it's going to be nothing. So keep that in the back of your mind. Automated, auto magic is just that. Who knows if it works? What do we do when it matters? We don't use automated anything. We don't use wireless in the data center. We don't use DHCP for IP addresses in the data center. We don't let the speed in the duplex setting of our servers be there. We hard code speed full. We hard code duplex 1,000 or 10,000 or 100,000 or based upon whatever speed we're doing. So we're always manually doing it because automatic is just that, broken. Imagine your servers changing IP addresses all over the place. This is what we're really talking about. So let's talk about another AWS service while we're at it. It's called Macie. And Amazon Macie is another fully managed data security and data privacy service that uses machine learning and pattern matching to discover and protect your sensitive data. Macie provides a list and inventory of S3 buckets, including a list of unencrypted buckets and publicly available buckets. And then Macie will apply a machine learning and pattern matching technique to help you identify things. Here's the thing. This is good. Why is it good? 16% of all cloud attacks are from misconfigured S3 buckets. Why? It's not that people don't know how to configure the buckets. They don't know what they're configuring and why they're configuring it. Because if all you do is like certification training is teach them the name of the service and how to configure it, and you don't teach them how it works, the person can't do anything other than listen to these suggestions. You have to know the why. See, the engineers are about how, because they build. The architects are designers. You can't design what you don't know how it works, because you have to know how every piece and part works, because they work together. Put the right stuff together, it's magic. It's like a beautiful orchestra. You put a rock group, a classical musician person, and a reggae musician, and I love reggae and classical music and rock, but especially reggae. Here's the thing, you put them all together, they've never played together, and you make them do a public musical show, it's going to be a disaster. But independently, they're going to be great. Now you put them together, and they practice together, and wow, you add somebody like a Ziggy Marley or a Damian Marley, and maybe the guitar of an Eddie Van Halen. Now we're getting somewhere. They practice together. This is cool. But you can't expect a symphony to be an orchestra together when they've never met before. So keep this in mind. Now we're going to talk about the service catalog. Now, the service catalog is a really good idea. So if any of you are like me and you're a little older and you've ever been in a system and you ran around with something called a sniffer or a protocol analyzer, and what you found was incredible things. You found like there were servers that you didn't know. You found that there were hidden backdoors that you didn't know. And people created remote access VPNs, bypassing all the firewalls that you didn't know. You'd be surprised exactly what happens. I can promise you, if you look on any system, you will find so many things that don't belong there that are causing you a security nightmare. So what AWS has, and I love this service, this is really great, is something called a service catalog. The service catalog will actually legitimately help you control what's placed on the network. So basically what happens, you create a list of machine images, servers, software, databases, and applications, exactly the things that you approve. And you give people access to the service catalog, and you only allow them to deploy the systems that are good and known to be safe and secure. So, well, I'm not a big fan of CloudFormation templates because I'm a Terraform person, because I don't believe in anything that only works in one cloud. I love, and Terraform works in all clouds. I love the concept of this service catalog. It's beautiful, because here's the thing. It only enables you to do the right things. So love it, love it, love it. It used to be like, hey, I want to put a system on the network. No, you're not allowed. Yes, you're allowed. I found you via the sniffer. So, those are the kind of things that I'm typically talking about. But in these particular cases, it's a little different. So kind of keep that in the back of your mind. This is a good thing. This is an exciting thing. We love these kind of things. So that's what we're talking about and why we're talking about it. So now let's talk about another AWS security service, and this is called the Systems Manager Parameter Store. And what we're talking about here is pretty important concept of your security posture as management of your licenses, your passwords, your database strings, that kind of thing. Because if this stuff gets in the wrong hands, you're hacked. So again, you don't want someone having a Word document on their desktop. Trust me, I've seen it. You don't want the sticky notes on the computer with all the usernames and passwords to the critical servers. Trust me, I've seen it. You don't want to put the person adding some open doors to get in. Trust me, I've seen it. You don't want somebody putting TeamViewer on the thing so it can be remote access. And trust me, a power company was shut down because of it, or a water company was shut down, I forget. Critical infrastructure destroyed from backdoors that users were doing that they didn't even think they put there. So the Systems Manager Parameter Store enables you to securely store this secret information, your passwords, your database strings. And what is the Systems Manager Parameter Store? It's another scalable, hosted, serverless environment where you can store your passwords, database strings, licenses. There's lots of ways you can do it. With cryptocurrencies, they have digital wallets, which basically are a wallet that's encrypted. That's a USB key, and everything is stored in the wallet. You unplug that wallet, you stick that wallet in your safe, and nobody can hack it because it's not attached. So same kind of concept, secure environment where you put these kind of things. Last thing we'll talk about on the systems manager parameter store for extremely sensitive information, encrypt it, and that's encrypt the systems manager parameter store. It stores it. Keep your code separated from your password. It provides an excellent means to audit, and it will provide the ability to track your password use. So before we get into those AWS services, and that's where we start talking about all the stuff, SNS, SQS, all kinds of AWS services. Let's take some questions. One question I did see pop in about the book. If you just register for the book, it'll take approximately 15 minutes for our servers to email it to you. We do that because we don't send them super fast to not get in anybody's spam folder. Also, people have said they've not received the book. Of the people that have said that to me, I've actually spoken to 12 of them. They received the email, but on the email it says, click here to download. And most people have not clicked there to download. They expect an attachment. So check to make sure you've received the email. And if you received the email, at least the 12 people I spoke to, they didn't read where it said, click to download. So please just click to download. So if you haven't received it, please look for that. But it takes 15 minutes by the time you press send till the time you receive it. So please keep that in mind. Chris, if you want to take some questions before we go to the next topic. Oh, well, no questions. So I'm ready to go to the next topic. But before I do any of you guys have any other questions on these security topics before I do? And if not, that is okay. Darrell Lassie, I'm not sure where you haven't had the book.
So I've asked people multiple times to send emails to our admin at gocloudcareers.net. So
okay,
they should, if they have not received it, they should send an email to admin at gocloudcareers.net.
Yeah, because we definitely want to make sure. Now, I have noticed on some of the people, they've used some pretty funny email addresses that don't look like real email addresses, but I'm sure Darrell Lassie did give us the right email address. So either it got attacked to a spam folder or it was hidden somewhere. So let's make sure we help her out. Send an email to admin@gocloudcareers.net, and my team will email it to you directly. What's the difference between the secrets manager and the systems manager parameter store? Let me think about that for a second, Nathan. So the systems manager parameter store is where you store your extremely sensitive information. Regarding the secrets manager, I'm not sure, Nathan. Chris, you can bring in the next one. We all focus on certain areas in the cloud, and I'll tell you what I know, and I'll tell you what I don't know, and I'm not afraid to tell you what I don't know because I don't want to give you any inaccurate information. But I think people are storing more of their credentials in this systems manager parameter store, but I'm not 100% sure on this one. So, are there any other questions? And if any of my blue wrenches are experts on that topic, and many of you may be, feel free to say so. Okay, well, if there's no more questions, let's do this. To make sure you're still awake, alert, and oriented, type hashtag cloud hired. I'd like to see about 150 of them real quick because there's about 150 of you right now. Show me hashtag cloud hired. And we'll be thrilled to keep moving on through our fun AWS Free Solution Architect Associate 2022 Bootcamp. All right, Tony, I'm always loving these cloud architects and cloud hireds. So the whole reason we do this is to try and help build the cloud computing careers for you. So cloud architect, cloud hired, it makes me happy. It's like music to my ears. Plus, I like knowing you're there, awake, alert, and oriented, and paying attention because, it takes a lot of energy to do this. And I'm thrilled to do it for you because I love this cloud computing community. This is the best career, is just really amazing. Praveen, anytime you call me guru, I find that the most wonderful thing. I know exactly what that means, Praveen. And I look to you as my big data guru every single time it comes to it. I find you as my big data guruji. So thanks so much for those really kind words there, Praveen. Okay, I'm loving this. I'm seeing some cloud architects. I'm seeing some blue wrenches. I see some cloud hired, cloud profit. I like that. I'm work with that. So a security group is actually can be layer 3, 4, and 7 all at the same time, because a security group is a stateful firewall. Tech with MUFAS. So basically what you're doing is you're specifying a source and a destination, a protocol, and a port number. So that's definitely a bare minimum, layer 4. Like a traditional, like a firewall. So, okay, so let's talk about some AWS applications and services. So I would say AWS applications and services. So let's talk about some of these. In this section, we're going to be talking about SQS, SNS, SWF, Elastic MapReduce, Kinesis, Elastic Compute Service, Elastic Kubernetes Service, Elastic Beanstalk, CloudWatch, CloudTrail, AWS Config, CloudFront, Lambda, Step Functions, Recognition, CloudFormation, and Certificate Manager. And how did any marketing person think of all these unique and interesting names? I have no idea. They must have spent a fortune for somebody to come up with these kind of names. So we'll talk about what these services are, how to use them, when to use them, and when you probably should never, ever, ever use them, and why a lot of these things are not appropriate in the multi-cloud environment, and while some of them are so amazing. So let's start with SQS, or the Simple Queuing Service. Simple Queuing Service is a message queue that helps decouple your application architectures. Why? If you decouple your applications, they scale more. They're more high availability. They're more, what's the word I'm looking for? High availability, high performance. And if one module breaks, you're still up and running. So much more agile, scalable. So when you can decouple whenever possible. Where did this decoupling come from? Well, at Cisco, back in 1999, they came up with the concept of the core, the access, and the distribution layers. Well, core, distribution, and access. And what was that? That was decoupling your network so things don't break. What are you seeing now? People are doing what's called the collapsed core, or spine and leaf, where basically you have the core and a new thing. They've avoided that decoupling network. And look at these huge network failures that we're seeing. So, sometimes you go to old school architecture, you decouple everything, and you're in good shape. So keep that in the back of your mind. What is SQS? It's a high availability, high scalability, pre-made queuing system for you to use. So pre-made, that's the key. You don't have to develop your message queue. Like an IBM MQ, it's a very similar kind of functionality and topics. So SQS is a message queue. So you got your web servers. They send their data to the app servers. On the way to your database, you drop these messages off in a queue, and then they drain the queue and enter the database when the database is ready. So instant scalability. And that's why we're using these things. SQS queues promote scalability. That's why we use it. So decoupling. So it's a message queuing service, which provides a temporary place to store your messages. So it's for transient storage. So when you put your messages in the queue, the default queue retention is 4 days, but you can keep it in there for 14 days. So imagine your database server goes down for 2 hours, but the messages are in the queue. So excellent. So this is a very good queue, and it's a standard queue. So SQS will enable right sizing of your applications. SQS will facilitate auto scaling. And here's the thing. SQS can look at the message depth in the queue and then scale your servers, not for databases, but for other things. So, normally we scale servers based upon CPU utilization, for example. But in this case, we can actually look at what's actually going on and scale when we need to based on accurate metrics. So Amazon SQS is pretty awesome. Great pre-made queue. Excellent on the AWS cloud. Effective. And Praveen, thank you for responding to that long before I got to it, because I'm thrilled you did. You're the right person for that. So thank you. So let's really think about, what this looks like architecturally, so you can get a better picture. So in this particular environment, you've got someone that goes to place an order. They go to the web server, they go to the app server, and then they go to an SQS queue on the means to be dropped off in DynamoDB. But at the same time, we could fan out the message using simple email service, basically an SNS service, which would send us to SQS, and then it would be. We could use the simple email service to send a thank you. So this is why we're using these things. We can use the queue to make sure we don't drop messages. And then again, we can send it to the right things. So let's talk about the kind of queues available with SQS. You've got the standard queue, which is the fastest. So here's what it means. Messages come in. They get out as fast as possible. Come in, get out, come in, get out, come in, get out. Now, think about it this way. If message 1 is 1,500 bytes, message 2 is 64 bytes, message 3 is 64 bytes, and message 4 is 1,500 bytes, we might get messages 2 and 3 before 1 and 4, and in a standard queue, because it might get through the queue faster. So if that's the case, we may have out-of-order messages. So if your applications can tolerate out-of-order messages, then guess what? SQS is perfect in the standard queue, maximum performance. But what if order mattered? Well, we can generate something called the FIFO queue, or first in, first out queue. And basically, this is going to have good throughput, but it's going to be much, much, much slower than first in, first out. Why? It goes back to that 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. Fast, 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 right? Do some calculus in your head. Can you solve a big kind of derivatives problem in your head as fast as you can add 2 and 2? No. So FIFO queues are ensuring order. It gets slow. So the more intelligent, the deeper the detail, the more work you have to do. Guess what? Now you're going to not, you want the speed. So if it has to arrive in order, use FIFO, but you're going to lose speed because you're doing it more. So keep that in the back of your mind. Now, when you're setting up queues, you can also set up something called a dead letter queue. And this is really awesome. Here's what a dead letter queue is. It comes from the post office. Let's say I wanted to send Chris a letter, and I got Chris's address wrong. Every time I send Chris a letter, I have to text him, Chris, what's your address? Because I don't remember. So, every single time. But this time, he texts me his address. And maybe this one night, the second time this year, I had a glass of wine, and I wrote his address wrong. And I sent it to him, and one thing's missing. So the post office tries to deliver it, and they're like, we don't know what to do. They put it in a box called the dead letter queue. And then from there, they can look at it and say, we send messages to Chris all day long. We know how to deliver it to Chris. That's what a dead letter queue is. And we can do the same thing. We get messages in our queue. They don't get delivered. We can create a dead letter queue so we can go back and we don't lose them, so we can use them for something else. So SQS, fantastic queue, cloud native service, absolutely beautiful in every single way, simple to use, great service. So how does it work? Message gets sent from the computer to the queue. Message goes in the queue and it gets scheduled for delivery. If the destination is busy, those messages hang out. We're just hanging out in the party. They're drinking cocktails. They're waiting to be delivered. Then somebody says, Ibadaikya, you can leave the queue and you can go to your home. You can get on that plane first class. So it's really the same thing. That's all that queue is. So when we set up the queues, the message can stay in the queue for up to 14 days. And the message will be pulled from the queue to be promised. So let's actually look at what this is going to look like. I know I probably showed you this in the first day, but it's important, so I want you to see it again. Here's the sender, which is typically your application server on the way to the database. Puts the message in the queue. Now the message is in the queue and everything is really, really, really good, et cetera, et cetera, et cetera. So then you send it to the receiver. And of course, it leaves the receiver and gets drained from the queue. So this is SQS. It's an AWS pre-made queue. And of course, it's pre-made. And obviously, you could have your own queue. And if you're using 3 environments and you had your own queuing system, your own custom queuing system, you could put that queue in a virtual machine on AWS, on Azure, and Google, and have a really functional, high-performance multi-cloud environment. So keep that in the back of your mind, that you can use this. It's a fantastic service if you're AWS, or you can use something a little more that will work with everybody. So typical environments, figure out one cloud, multi-cloud, but the SQS queue is a relatively nice queue, although it's relatively expensive because it's pre-made. So when do you use SQS? To assist with capacity planning, application scalability, to make sure messages are not lost because systems are overloaded, to optimize your costs so you can right-size your application so you don't have to overbuy, because otherwise you need much bigger servers. But if you can deposit them in a queue and they can sit there for 4 days to 2 weeks, you don't lose them. You can use it to basically Determine message depth and queues to determine if you need to auto-scale your applications, which is great. Keep that in the back of your mind. It enables you to be able to handle spikes, like 1 million orders come in for a minute, and then it slows down to 100,000, process those orders and don't lose them. And it's really good to reduce the write load and the CPU load on your server. So keep that in the back of your mind. That is Amazon Simple Queue Service. So the next service we're going to talk about is going to be Simple Notification Services. And yes, Ivadaikia, if you've got a big data question and Praveen's here and he's willing to ask it, Praveen is the guruji of big data architecture. So Praveen, if you're here and you're answering things, thank you so much. I'm very grateful for you sharing your expertise. Let's go back to SNS, or Amazon Simple Notification Service. So Amazon Simple Notification Service is a managed service to basically deploy messages in between services. You've heard of message delivery services before. There's lots of them out there. Basically, it's used to decouple your messages between microservice applications. You can use it to send an SMS to somebody, an email, a push message example. And realistically speaking, it's going to communicate and facilitate communication between senders and receivers. So the way it works is like an email list. There's publishers and there's subscribers. You subscribe to the list, and when I publish the list, you receive it. Kind of like YouTube, kind of like LinkedIn, basically anything else. That's the way it works. So the publish-subscribe model enables the notifications to be delivered to the people that want it via push notifications. So make sure there's that. SNS consists of 2 components, the publishers and the subscribers. The publishers send a list, the subscribers receive it. No big deal. So we don't need to make it overly complicated. So here's what it's going to look like. I publish to the topic. It can go to a queue to be fanned out somewhere else. Multiple people can get a notification that something occurs, and heck, I can even kick off a Lambda function, et cetera, et cetera. So SNS can be used to fan out messages, but it can also be used to send notifications such as emails, et cetera. Talk a little bit more about SNS platform functionality. SNS is a high availability platform that by default runs across multiple availability zones. It can be used to fan out messages I described to subscriber systems or customer endpoints, SQS queues, Lambda functions, etc. SNS allows the creation of filter policies so that you only receive the notifications that you want to. Because in these systems, you can have logs that'll send out thousands of notifications per second. And you're not going to really want to look at that. So you can send the ones that you need to. Otherwise, you're going to get alert fatigue, like the doctors have. And that's why electronic health records now cause more medical errors than before, because we've been trained to ignore everything because it's alert fatigue. Plus, it's really easy to accidentally click 10 versus 100 milligrams and make a big mistake. But that's neither here nor there. So SNS allows the creation of filter policies and encrypts your messages to make sure that nothing happens. Let's talk about some common SNS use cases. Applications and systems alert. For example, send me an alert every time my CPU hits 80%. Message fan out. Message comes in. I send it to a Lambda function and an SQS queue and an email all at the same time. Or I want to send a push notification to a mobile phone. Hey, everybody, we're having a flash sale. So that's what a push notification is. Or my cat Cindy just did something really cute. Push a notification. You see her. You can see her doing cute things with her paws. Whatever. I don't care. But that's what a push notification is. So now let's talk about Amazon Simple Workflow Solution. So imagine this. Here's your task. Do this, do this, do this, do this, do this. So let's say wake up in the morning, go to physical therapy, write a book, give a presentation. Let's say that's your workflow. So what is the workflow solution? It can basically guide it. So task is done, send it to the next task, send it to the next test, send it to the next test. And by doing it this way, you can find yourself scheduling your task, which helps you automate. So lots of ways to automate. Most automation is done by customers coding their own, making it exactly what they need. But if you're dealing with the cloud, one of the things that people like about the cloud is they don't have to develop anything because half of it's pre-developed. So they go to the cloud because it's not cheaper the cloud to rent their stuff than it is to use their stuff. But it becomes cheaper because you don't need as many programmers, you don't need the network engineers, you don't need as many people, all your expensive people. You can reduce your staff because you can automate some of these things. So kind of keep that there. So SWS is a workflow management solution. It enables the coordination of different tasks across distributed systems. SWF coordinates the execution of tasks in these distributed systems, and it mitigates the need to code your own application, but you're using theirs. It might be cheaper to develop yours and use it across 3 different clouds than it is, for example, for something like this, where you're going to just use somebody's prepaid service. But it's a good service. It's pre-made. If you're someone like me and you're migrating to the cloud because I'm actually running an OpenStack cloud. I manage my own cloud because it's about 10 times cheaper for me to run my cloud than I used to use the Amazon cloud. But my network's pre-built. I'm a network architect and a cloud architect, and it's cheaper for me to design a cloud than it is to outsource and rent somebody else's cloud. Then again, if any of you guys are landlords or girls are landlords, you buy a place for a price that costs you $1,000 a month, you rent it out for $1,300 a month. So what are the cloud providers doing? They buy a server for one price and they charge you more. Same thing, they rent it to you. What is a cloud? Rent a data center. So let's pretend this workflow. This is a very common workflow for people like me. I create a video. I upload the video. After I upload the video gets, say, put into an S3 bucket. From there, let's say I send it to another thing, maybe via a Lambda function, and the video gets converted into, from uncompressed video, maybe to an H.264, H.265 codec to turn it into a compressed MP4 video. Now, next, I want to ship it. So we have another Lambda function that was scheduled in the simple workflow solution to something that's going to add subtitles to it. Once the subtitles are burned in, we kick off a Lambda function to send it to another bucket. And that Lambda function then sends me an email, kicks off an SNS notification, sends me an email to say, Mike, download your transcribed video with burned in captions. So that's kind of what we're talking about. Now, the next thing that we're getting into, we're starting to get into some kinesis and some map reduction functions. So I'm going to do this. I'm going to talk about elastic map reduce. And then I'm going to tell you that there's lots of ways that other organizations actually do this. So what we're going to talk about is as follows. Let's say you have a big data environment, big data, and you're going to be creating, say, data lakes. And let's say you've got your relational databases, your NoSQL databases, you've got some streaming data, what have you. And let's say you've got some object storage and a few other things. All of these data is in different formats. And, you know, it's not clean. I mean, it's clean in one place, another place, another place. So what typically happens is that you require some kind of mapping and reduction function that basically is going to pull out the elements, create a data catalog. And I'm not Praveen, this is his world, but you know, we're going to pull out the elements and then we're going to clean the data, catalog it, and create a data lake. So typically what happens is organizations have something called they use Apache Spark and they write some Python scripts and they create their own mapping and reduction functionalities for this. And that's typically what's done in the industry. And if you're going to be running in a multi-cloud environment, like you most likely will be, elastic map reduce, you're not going to use because you're going to write a Python Spark script or your big data people will. But if you were just on the AWS cloud and you were just using AWS services and you didn't have the people to write their Python Spark scripts, what you would use is AWS Elastic Map Reduce, and you would still have to code your scripts, but it would be easier. So the theory is you use a service, it's a pre-made service, and then this service does all your mapping and reduction for you automatically. But if you do that, it's AWS specific, and maybe you want to use multiple clouds. So you're probably better reaching out to a big data person and having them remember those Python Spark scripts for do it. By the way, we have a really, really great big data architecture on our YouTube channel. Chris, or one of my blue wrenches, can you find the video that I did with Praveen where he talked big data and creation of data lakes? It was a couple hours discussion. I really want people to see it and help them build their cloud architect careers. So if one of you wonderful magical blue wrenches or Chris can put a link to that video with Praveen where he described it, I'd be grateful because it would be such a service for the cloud computing community. Because this is really what we're kind of talking about over here, where we're talking about basically pulling thing from one thing and placing it into something other. But you know, this is not going to do it justice compared to that discussion that we had with Praveen. So with the last thing that we want to talk about is streaming data. Now, streaming data is Kinesis or Kafka. And this is a pretty big topic. So here's what I want to do before we get into the streaming data piece. It's 2:47 today. I would like us to basically open it up for questions and answers. Questions for me, some questions from my magical blue wrenches. Thank you so much, Chow. Please see that video that Chow just posted of Praveen. He and I were talking big data, and I should say Praveen was educating me along with many, many other people on big data environments. He is the absolute expert. He's done it for decades. So please catch that video. It's exceptionally good. Don't get me wrong. He's an incredible cloud architect, but he's also an exceptionally good big data architect. So I want you to see that video. It's completely free. I learned from it. And he teaches me every day about big data, just like I teach the world about networking, security, and infrastructure. So, go see that video. Highly recommend it. Thank you so much, Chow, for taking that there. So, who has questions? Let's provide some answers. Faisal G, could you explain it, plays a bit about what's the next generation firewall and how it works in the real world? Yes, absolutely. So, Faisal, do you have a credit card? If you did, which you probably do, here's what happens. If right now, if you decided that you were going to go fly to Greece, and when you went to Greece, you tried to buy a $10,000 coat and a $5,000 Armani suit, and then you left Greece and you went to Dubai and you bought a $10,000 necklace, and a day later you went to Ethiopia, and a day later you went to Johannesburg, and a day later you flew to Sydney, and while you're in Sydney you spent $25,000 on your credit card, and that's not your normal pattern of behavior, the credit card company is going to send you an alert. Did you mean to do this? Did you mean to do this? No. And you're going to say, no, my identity's been stolen. So that's heuristics. So if you've ever had a credit card alert notification that shows you that something is scary, click yes to approve. That's what next generation firewalls do. So normally we've got a firewall and it's just basically a wall. It allows our stuff to go out and come back, but it doesn't allow anybody in unless you specify it in your demilitarized zones, etc. The next generation firewall is just this: admitted, denied, admitted, denied, admitted, denied. Smooth and wrong, like driving the car, having fun, firewalls relaxed. Admitted, 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 denied, 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 admitted. Okay, now, something's coming in. This looks really scary. Add a new wall. Activate the Navy SEALs. Bring in the SAS commandos. Bring in some Israeli commandos. Get them in there and thwart the attack. Call for help. So that's what we're really talking about with the next generation firewalls. Normal firewalls, yes, no, yes, no, yes, no. Adaptive firewalls, yes, no, yes, no, yes, no. Whoa, not normal behavior. Stop. Virus comes in, your sandbox will test it in a virtual machine. Stop. New access list. Reset a TCP connection. Stop, stop, stop. So Faisal, that's the difference. The next generation firewalls, like your credit card company, if you went to spend $24,000 in the next hour, and it's not something you do all the time, your credit card company will block the transaction because it's applying heuristics. These heuristics or pattern matching and behavior matching is the same thing that the next generation firewalls do. So lots of alerts. So what's the good about next generation firewalls? They stop attacks. What's the bad? Well, it's not uncommon for me to go from New York or to go from Palm Beach to Virginia to San Jose to New York to London to Dubai in a week. I used to do that with Cisco all the time. And here's the thing. My cards were used to it. It was no big deal. Then I got sick and I couldn't travel for 6 weeks. Then I went to travel. I made it to England. I bought something at the Thomas Ping store. Ding, 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 ding. It was denied. And then I had to call the credit card company and allow it through because they're looking for patterns of behavior. So it's heuristics that we're talking about, and that's exactly what we're talking about. So Faisal G, I hope I answered your question. If you want to ask it a little deeper, I am happy to answer it in any way. So hope I answered your question. Chris, if you want to bring in the next one. Mark, you got the AWS Cloud Practitioner last month and watching this training all week. Do you suggest I study directly for the Architecture Professional and skip the Associate cert? Generally speaking, I have people start with the Associate and go straight to the Professional. If you've done the Practitioner, I'd almost have you go straight to the Professional. Just make sure you pass it. And here's the reason. The Associate and the Professional are very similar. So I don't feel like it's worth spending 2 months of your time studying for an associate exam and then spending another 2 months of your time studying for the professional. I think you can go to the professional in 2.5 months. And since the average cloud architect earns $600 a day, and a good cloud architect can earn 2 to 3 times that if they've got the right leadership skills, business acumen, emotional intelligence, architectural design skills, presentation skills, ROI modeling skills, etc. Every day you're not working is a small fortune. So if you've got all that business acumen, leadership, and emotional intelligence, you can earn $1,000 a day. If you spend 2 months wasting your time, that's the equivalent of $40,000 lost. So I suggest you go straight from whatever you have to the professional. If you were brand new, I'd say go to the associate and the professional, but we always must think about the opportunity cost of our time. If you do certifications that are unrelated to you, they not only decrease your brand value, which kills your salary, which is even bad, but they take time, and time equals money. So the shortest distance between 2 points is a straight line. From the CCP last month, be rock solid, go straight to the professional. You should be good, Mark. That's what I would do. Angelo, will you please cover the difference between SQS, SES, and SNS? In your experience, it comes up in the exam, and it's important to know. Actually, it is important to know, and I totally agree. SQS is a queue. So you've got a server, you stick a message in the queue, you send it to the database. Done. That's a queue. So Angela, in England, when you get on a plane, they say, please form a queue. The queue is, her person that gets on the plane first, the second person, the third person. So that's SQS or queuing. SNS or simple notification, Angelo, is I made a brand new pizza, a Greek pizza, but it's still a pizza. So I send you a text message via an SNS that says, Angelo, the Greek pizza with feta, spinach, and tomatoes is ready. And you go pick it up because you got an SNS. So the simple notification service is about sending messages to people. Now, SES or simple email service is, Angelo, the pizza's ready, here's your email. So SQS is a message retention place, like the queue to get on the airplane. You get on a line and you get it delivered. SNS or simple notification service can either spread your message out or send you a text message or a push notification that says, come get your pizza, it's ready. SES is basically simple email, which is get your pizza via an email versus a text message. That's really it. But that is a really great question, Angelo. I hope I've answered your question. If you've got further questions, ask me. I'd love to cover them. I just want you to be super successful. Roberto, always good to see you. Can I explain the conflict between Microsoft Active Directory and Azure Active Directory when deployed? Unfortunately, I can't, Roberto. I didn't know there was a conflict between them because Azure AD usually connects very well to Microsoft AD, so I definitely can't explain that one. That's not an area where I actually work. Chris, you want to bring in the next one?
There's not any more right now.
Okay, it's really hilarious. When I first started out as a network engineer and a network architect, the network people were so secure in making sure that they were experts on the network that I remembered I started networking and I asked somebody a computer question. They're like, I don't know anything about computers. I only know networking. Like, wait, I'm like, why are you building the networks? And they said to plug the computers in. But for us, I only need my computer for telnet and ping and traceroute. So kind of keep that in the back, which is really funny. So what was that? That was what I would call be the answer of completely looking at it the wrong way, pretending you only know one thing when we should know more. But what did come out of that? The people that acted that way became experts on the network, and they were the world's best, and they designed systems that never crashed. So here's the key: know your things and know it well. Kishan, will we be learning only AWS Cloud or also Azure or Google Cloud? Well, if you were in my career development program, you'd be learning all of them. But since we're on YouTube and we're doing an AWS Solution Architect Bootcamp, we're going to be teaching AWS this week. Now, having said that, we've talked about similar services on Azure or Google. We talked about virtual machines, for example, or storage types of things. But if we're doing an AWS bootcamp, it'll be covering AWS. When we do an Azure bootcamp, it'll cover Azure. If we're teaching cloud architects like we do in our cloud architect career development program, which is very different than getting somebody certified, we would teach all clouds at the same time. But we always, whatever we're architecting, of course, architecting and architecture, We have to build the architecture based upon the goals. If the goal of this is getting people to pass a certification exam, then we have to make it about that certification. If the goal was teaching you how to become an employable cloud architect, then we need something bigger like my 500-hour cloud architect career development program, because what it takes to be an architect is way, way, way outside the certified solution architect professional. So there's that. But that's why we're only teaching AWS on an AWS bootcamp. Chris, you want to bring in the next one?
There's not a next one.
Really? Okay, well, guess what? If there are no next ones, and that's quite okay, let me say the following. Remember, Chris, we have tomorrow at 12 p.m., right?
That is correct.
The next day is tomorrow. Let me remind you of 3 things before I ask you to type your cloud architects and your cloud hires. Let's remind you of the completely free AWS Certified Solution Architect Professional Bootcamp. Includes the associate and professional all in one book. The link is in the description below. If for some reason you didn't get one, send an email to admin@gocloudcareers.net and we will email you one. So I want to make sure that you get it. Please, please, please join us for the next CCNA course when we do it. Please join us next week for the free interviewing session. Please join us for the free subnetting workshop that you asked for. And I'll still do a BGP workshop, but I'm going to do it after the CCNA. And you guys know a little bit more networking to make you retain more of it. So there's that. So Chris, I know we have a couple more labs that people want to see. When are we going to be releasing them?
Tomorrow.
Tomorrow. So tomorrow we'll be
at
releasing
the
some
end
more
of
labs at the end of the boot camp.
Mhm.
And remember, we have that contest where we're going to give 1 free admission ticket based upon the best social media post that we received for the contest. And we will announce that on the YouTube announcement tomorrow. So if you participate in that contest, make sure you're here. Chris, am I missing any other advertisements or free things that we can do for the community?
Design experience webinar.
Oh, yes.
on
Don't
Wednesday.
miss this. Don't miss this. So next week, is it Wednesday?
Yes.
On next Wednesday, we're going to have a multi-hour. We're going to invite you to a cloud architect experience. If you want to know if you have what it takes to get hired, guess what? We will show you. We will have you interview a CEO, a real CEO, about a business, and then they'll give you a situation, and you'll be tasked to design it. And I will help guide you. You'll work together. My students will be there to help out those in the background because we expect to need my students to help out. And you'll learn what it takes if you're ready to become hired as a cloud architect. So I want you all hired. I want you building great careers. Let me tell you, the cloud architect career, the enterprise architect career, the network architect career, and somebody always asks, what's the difference between a solution architect and a cloud architect? A solution architect only knows one cloud. Cloud architect knows all the clouds. So there's that. Chris, did something pop up? Looks like I saw something. Do we provide job support post-placing? We have the ability for people after they're hired under certain circumstances to reach out to us under certain circumstances. But realistically speaking, our job is to get people hired. And once they're hired, they know what to do. Now, typically speaking, when somebody gets hired, a lot of times we let them stick around in our program for a month or 2. And the reason we do it sometimes, if they want to, is maybe they're not sure for the job. And if they get a big architecture in their first couple of days, they can come to the class and we can dedicate that class to their real life architecture, which we do lots of times for our students, because we want to know that our students are capable now and getting promoted. So thank you so much, Abigail. I'm thrilled to have you here. Hand of God, thank you so much. Always have some nice things to say. See you tomorrow. Kelly, thank you so much. I'm so glad you were here, and I'm super grateful you were here. And of course, thank you for all you out there and all of the people that helped the team. Kenya, thank you so much. Kenya, I've actually been meaning to call you, so let's make sure we can speak very soon. Derek, thank you so much. It was a wonderful Friday, and anytime you're around is great. Melanie, thank you so much. I'm really grateful for your kind words. Angela, what value does hands-on experience have in becoming a cloud architect, not aiming to be a cloud engineer? Angela, that is the best question I have heard. So the reality is this: architects are system designers. So you're not going to teach a building architect how to cement bricks together and really cement and dig ditches, because it's not their job. So why does it help? It helps for one reason and one reason only. When you go on a job interview and the employer says, have you ever done this? The answer says yes. So doing these labs on the AWS Management Console, honestly, as architects, we're never going to do them. I've done them. I have my students do them in many cases for the simple reason. So when that hiring manager says, yes, have you done it? They can say yes. Now, Angelo, otherwise, I don't see any value in doing labs on the AWS platform for architects. Now, for engineers, that's all they're going to do, and they need a lot of it, where architects need much more design experience. Hands-on for me is drawing boxes, giving presentations, doing ROI models. And generally speaking, it's better to know how to do your job than somebody else's job. But one last thing, Angelo, when you do the kind of labs that we do, such as setting up server virtualization, or building your own cloud, or building firewalls from scratch, not the simple things where you click a few buttons on a cloud thing, but doing it the way we do, it teaches you how the firewall works because you get to experience it. Once you set up these servers, you know how the servers work. Once you set up containers, you know exactly what they are. Once you set up a firewall, you can know exactly what it is. Once you set up Active Directory, you understand IAM. And once you build a cloud, you understand the cloud. And once you connect your cloud to your Active Directory, guess what? Thank you so much, Roberto. Then you know it all. So it does give you an experience to actually tie the theory with reality. So I think there's value in that too. Thank you so much, Darren and others. Carl Jr., you're learning more from you and just simply from my explanation other than the courses you bought. I'm so happy for that. You greatly appreciate everyone at Go Cloud Architects. Thank you, Carl Jr. I appreciate everybody over here too. Thank you so much, Kelly, Ellie. I love that name. Wow, it's great. Nitro Pen, always great seeing you. Melody, thank you so much. And yes, thank you, Chris, for coordinating this. Tosin, thank you so much. And also thanks to Chris and all everybody out there helping. Oh, Robertson, great cloud security guy. Thank you so much. Avishi, always appreciate all the kind things you say over there in Maritas. Ray, thank you so much. Marla, thank you so much. Marla, thank you so much for yesterday. Leo, appreciate everything you do and thank you so much. Chigo, thank you so much. Rafael, thanks so much. Mervin, thank you so much. Glad you got the link and perfect. I'm glad you received it. Becky, thank you so much. Cloud Hard. Mario, Cloud Hard, it's good to see you. Thank you so much. You do it long enough, it becomes second nature for you. It will for you too. Charles Simpson, thank you so much. Raul, thank you so much. Have a wonderful day. NitroPass. Is it best to have an architect specialty like an architect? NitroPen, here's the thing. As a rule, specialists always get paid more, are respected more than generalists. So generally speaking, almost exclusively yes. Now, what is the best specialty to be? If you really want to know what the best specialty is, it's business acumen and leadership. So the difference a ton of years ago, I had a manager, he pulled me in a room and said, Mike, do you know the difference between a $150,000 architect and a $300,000 architect? And this is 20 years ago. And I said, don't tell me. And he said, leadership, emotional intelligence, executive presence, energy, enthusiasm, and passion. So there's that. So keep that in the back of your mind. So the better your business acumen, the better communication skills, the better your leadership skills, that will give you the maximum growth. Now, after that, what's the next best thing for you to do in your career? The next best thing is to become an industry expert. Maybe you're an expert on healthcare. Maybe you worked in a bank. Maybe you're an expert on law. If you had a past career in an industry and you can combine that industry knowledge, industry acumen, combine with that, like for me, I do consulting on designing medical grade networks. Why? Because I can practice medicine and I'm also a network architect. You combine that together and that's my specialty. Then I've got the business acumen, so people know me as the business person, the healthcare expert that designs healthcare architectures. But so it's build your brand. So otherwise, you can specialize on technology like networking and security. I'm not a big database person, and I don't recommend software things as a rule for career potential. Otherwise, I think they're great. Looking forward to seeing you there, Ketar. I haven't seen you there in a while. Jamal, good to see you. Leo, thank you so much. Eva Doikia, Cloud Hard, thank you for everything. Thank you so much, Eva Doikia. Rajesh, thank you so much. I do try and keep them entertaining because I know how hard it is, so thank you so much. You joined your course, Ahmed. That's wonderful. Look forward to getting you hired soon. Definitely look forward to getting you hired. See you in class on Tuesday. Marley, thanks to the Blue Wrench family. Yes, I agree. The same thing. Rohan, thank you so much. I feel the same way. All of you guys inspire me every day. And yes, Jamal, thank you for the blue wrenches. They are some of my students. They are amazing. Chow, thank you for everything. Cecilia, thank you so much. Kay Cast, you're more than welcome. And Rajesh, Cloud Architect, that makes me happy. Life is good, the cloud is good. That's what we should post as our model. And Marla, I'm so grateful for all your help. You provide so much help and do so many things for the community. Soga, thank you. Andrew, thank you. Jimson Mentor, thank you. Georgetta, thank you. Avishi, that's what I want this to be, the Harvard School of Cloud Computing. And you know what I love? You're over there in Maritas. We've got people in India, people in Johannesburg. Out of the park. It's as good as it gets. Thank you, Mario. Eva Doikia, I love that. That's really great. Saeed, Cloud Hired. Shukran. Mr. Geeth, thanks so much. Hand of God, may the universe always continue to project its most bright light and positive side to you and your team, Mike, Go Cloud Architects. I don't even know how to say thank you to that. I'm so and Dean, super thankful. The answer to yes was your question. We'll have to figure out how to sync up, but I have the solution for you. Ben Christopher, I love that. She will give access. I can't begin to comment enough about those blue wrenches that were there helping you today. I'm so grateful for their help. I love that, Ividoikia. Love that. Yeah, that's the thing. You know, the cloud is just the tech piece, but it's the leadership and the emotional intelligence that's really the key. And here's the thing, and I'll stay on this for a minute, Chris. Since nobody hands us a paper or requirement documents, the ability to know what we have to design is purely based upon our communication skills, our ability to ask questions in an open-minded, non-judgmental thing. So, you know, when people say, what's your job? I say, I open the conversation, I get people babbling, and I take rapid notes. And then when things I don't understand, I confirm, I take more notes. Best job of an art is there. Now, I'm not a programmer, but in programming, they used to say garbage in, garbage out. So the better your leadership, better your emotional intelligence there. And the reason the leadership matters so much is not only are you going to be guiding the customer, but you're not going to be building these things, and you're not going to be doing and you're going to have proof of concept, but you're not going to be the technical person. So you might do a proof of concept and need 50 cloud engineers to do the work for you, and they don't work for you, but you got to convince them to work for you. You need to make sure they're taken care of, get them promoted, even though they don't work for you, so they'll continue to want to help you. So there's leadership for that. You're going to have to borrow resources in your company. I need this expert, this expert, this expert, and it can cost your company millions of dollars for the team that you need. So you need the leadership and the emotional intelligence and the sales skills to convince your company to get you those resources. That's why it's critical for the leadership, emotional intelligence, communication skills, for the architect, where the engineer should have them, but they can get away with it because they have much more technical skills. So if they have less of this, the world values them for their technical ability. The world values us for our digital transformation ability, improving the business. So for us, it's essential. It's more important than our technical piece, actually. Thank you so much, Kelly. Chris, if you want to bring in the next one. Thank you so much, Ben. Mr. Binary, thank you so much. Nitropana, always appreciate you being here. Cloud Hired, Kenny, no. The Blue Wrenchers, yes. They have done so much to help out this week. I'm so thankful. Thank you. Yes, Cindy password. I obviously wouldn't do that, but I got to tell you, boy, is she a sweet little, cute little thing. Chris, do we have a picture of my cat, Cindy? If you don't have one, that's totally okay. But she's really special. I mean, I'm actually thinking of making her a LinkedIn account and talking about her great little purring and cable unplugging things that she likes to do. Maybe make her the chief feline officer. I don't know. I've been thinking about it for fun, because I don't really have a CFO yet. There she is. That's my little Cindy sitting on my chair, ready to type on my computer. That's her. That's what she looks like. That's the green screen behind me. That's my beautiful little daughter. Note those pretty ears. Yeah, Kenya, when I even teach our class, I end up crying on a Friday with how wonderful all the students are. They found a family. They help each other. They study. They're helping each other practice, interview each other. I love it. Mark, thank you so much. Tyrone, I'm so happy to see you. Haven't seen you a while in South Africa, but I'm thrilled you're here. Thrilled you're here. Okay, so maybe you can tell us where you're from, and then we'll close the day and see you back at noon. I always love knowing where you're from. Cat hired. Yep, that's our new thing. Cat hired. I like that. Yeah, she's pretty smart. Pretty manipulative, too. She knows exactly how to get me to do anything she possibly wants. Chow's in Texas. I love that, but I think she's from Vietnam, which is also cool. KT is in Washington, D.C. Love that. I'm in Port St. Lucie, Florida right now. Tom is in Holland. That's fantastic. Olivia has a really cool last name. Dean is in Wales. I saw Cardiff, so I figured that. Praveen's over there in Philadelphia, Pennsylvania. We're at my old stomping grounds. Bulgarian in Denmark. Colombia. Wonderful, Mario. Cat hired. Yes, Valentine. United Kingdom. That's fantastic. Cloud, Cindy hired. A fantastic. Marla's over there in Atlanta. That's correct. Leo's in Brazil. Ahmed's in Dallas. I love the cat hired. Ransom's in Dallas. Kelly's in Ohio. Fantastic. Haven't been to Ohio in a little while. Leeds, UK. It's a place I've spent a lot of time in. Nigeria. Wow, what a great place. We have so many wonderful students from there. Dominican Republic and New York. Love this. South Africa. Wonderful, Valentine. Asheville, North Carolina. That's a beautiful place, but from DC. Charlotte, North Carolina. What a beautiful place. Almost moved there. UK Queen. Fantastic. Silver Spring, Maryland. I'm loving this. Atlanta, Georgia. In India, I love that. And Phoenix, Syrian living in Germany, how wonderful. East London from South Africa, I love this. Paul's from DC, love it. Cindy is hired, thank you so much. Freehold, New Jersey, wow, I haven't been there in a little while. Bethesda, Marion, I've spent a lot of time there. Nigeria, fantastic. Tech with Mufaz, love that. Bryn Mawr, PA. I've got half of my family there. Atlanta, Georgia. Wonderful, Richardson. Theo, Silver Spring, Maryland. Fantastic. Nike's in Texas. That's right. Stockholm, Sweden. Wow. Thank you so much, Angelo. We're so appreciative of you being here and all your kind words. India. How great. We got all these people. Cat hired. Cat called architect trained hired. VNHG. I love it. It's all about the end-to-end Lagos, Nigeria from Tosin. That's fantastic. I mean, seriously, just such a wonderful community. And you know what the tech community is going to look like? Just like this. All of us, all over the world, the cloud architects that, you know what? I say we all form a family and help each other in every country, no matter where you're at. Andrew, fantastic. Puerto Rico, I'm loving this, Anthony. How wonderful. Ashland's in Connecticut. It's a nice suit there, Ashland. Sharp. We do need to have Zoom for cats, Abigail. We do. You know, I kind of had this theory. I had 2 glasses of wine about a month ago, and I don't really drink. And after 2 glasses of wine, I thought the world needs more cats. Because if everybody had a cat Cindy they were playing with all day long, they couldn't be upset or angry with anything. They would just be playing with their little cat and happy. Chris is the best second in command. He's unbelievable. You know, absolutely. Kelly, cloud hired, cat hired, cloud architect. That's exactly what I like to see. KFlow, Ethiopia and Virginia. Oh, the good news is you're so close to DC over there. I have to have some of my Ethiopian friends that live in DC bring me things like Sparrow and Burberry. Unless one of my friends goes to Ethiopia. So that's terrific. Okay, so we saw where you're from. It's been a wonderful, wonderful day. Unless there's anything else, Chris. Your cat is named Simi. I love that. Especially, that's a great name for a cat.
It's like as almost a cross between Sunny and Cindy.
I really love
Almost.
that. And you know, it's funny because we had some Ethiopian people here. Ethiopians typically add an I at the end of the name when they like someone. So whether I'm calling my good buddy Ephraim, who's one of my best friends, I call him Effie, and he calls me Mikey. So I kind of like that name for a cat too. Jazz is a wonderful, wonderful, wonderful member on my team. So thank you so much, and love you guys too. Thank you so much. I really want to make the world the best cloud architects. I just love this industry. It's just so special. Thank you, Marla. And Abigail's got a beautiful cat. I've seen her cat every once in a while. She comes to class with her cat. Her cat looks like mine, but it's bigger and furrier and fluffier. It's a beautiful cat. You know, VC, I've actually got a special group of CXOs that I'm working with right now, because that's my goal. I want them all to be there, and everyone, I want all my architects spread at every company, all family members, all friends, all getting each other's promoted together, all building a career and a life and a future for each other. It was a wonderful day, Yubadoikya, and thank you for all your assistance in everything. Anything else, Chris? Okay, no. So I'm humbled by all of you wonderful folks that have spent the week with us. I'm honored for your presence. We're going to go on tomorrow. I think we should be able to fail out between 12 and 3. After that, we have a bunch of labs that were done by my good friend Alonzo, who's heading up our cloud engineering program, which is coming very soon. So it'll be great. So join us tomorrow for class. And after that, we'll have some labs for you to do. And of course, if you get the book, there's 30 good labs for you to do in there. We bias things for cloud architects because that's our world. But, you know, we want you to have it all. We want you certified. But most importantly, get yourselves cloud hired. Have a round of applause for yourself. You sat in a chair for 3 to 4 hours each day. It's not easy. I tried to make it as entertaining as possible, but it's not easy. So have a round of applause. I'll see you at noon tomorrow. And let's get you all cloud hired. Have a wonderful night, and I'll talk to you tomorrow.